Good. My God. Recording started. Bismillahirrahmanirrahim. Assalamu alaikum and very good morning, distinguished dignitaries on the dais and off the dais, esteemed guests, dear delegates, and fellow colleagues. We, Dr. Syed Shafi and Dr. Kamla Rawat, on behalf of the organizing committee, welcome you to the international seminar on recent advancements in chemical and life sciences organized by Department of Chemistry, School of Chemical and Life Sciences, Jamia Hamdard, in collaboration with Indian Society of Analytical Scientists, Delhi chapter. We are privileged to have with us Janab Imran Hussain Sahib, Honorable Minister for Food and Supply, Delhi Government, as the chief guest today. So we welcome you, sir. We cordially welcome our guest of honor, Professor Dr. Faizan Ahmad Saab, an eminent scientist who doesn't require any introduction to the scientific community. We welcome you, sir. We are fortunate to have Dr. Rakesh Kumar Khandal, former director, Sri Ram Institute of Industrial Research, as the keynote speaker. We are ever grateful to the patronage and support of our dynamic leader, Honorable Vice Chancellor Saab, Professor M. Afshar Alam Sahib. We welcome you, sir. We are also joined on the dais by our Dean, School of Chemical and Life Sciences, Professor S. Raisuddin Sahib, a notable scientist in his research domain. We extend our warm welcome to Professor G.S. Kapoor, Executive Chair, ISAS Delhi Chapter, and Dr. J. Christopher, Chairman, ISAS Delhi Chapter. We welcome you, sir. We also welcome HOD, Department of Chemistry, and also the Seminar Chair, Professor M.S. Alam, Organizing Chair, Dr. Zina Humaydi. We welcome you, sir. Let us begin the day with a harmonious start by invoking the blessings of Almighty, and I now request Janab Abdul Malik Farooqi Sahib, Imam Rabia Masjid, to recite few verses from the Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم وفي الأرض قطع متجاورات وجنات من أعناب وزرع ونخيل صنوان وغير صنوان يسقى بماء واحد ونفضل بعضها على بعض في الأكل إن في ذلك لآيات لقوم يعقلون. एक आयत पढ़ी अभी मैंने आपके सामने, जो इसमें मैसेज है वो मैं आपके सामने अपनी ज़बान में रख रहा हूँ। ज़मीन और आसमान का बनाने वाला कह रहा है कि ये ज़मीन जो हमने बनाई है, इस ज़मीन में हमने ज़िंदगी रखी है। ये ज़मीन जीती जाती चीज़ है और इस ज़मीन के टुकड़े के अंदर हमने ख़ास बात ये रखी है कि पानी इसको एक ही तरह से मिलता है, लेकिन वही पानी किसी पेड़ में कड़वा फल निकाल देता है, वही पानी किसी पेड़ में मीठा फल निकाल देता है। ये हमारी कुदरत है कि इसी पानी से नीम का पेड़ और करेले का पेड़ भी निकल आता है, इसी पानी से खजूर का और अंगूर का, इस चीज़ का मीठा पेड़ निकल आता है। हमारी कुदरत पर कौन लोग गौर करते हैं? जो मैंने ये आयत चुनी वो इस आखिरी हिस्सा है, वो इसका कुरान कह रहा है कि इन चीज़ों के बारे में वो लोग गौर करते हैं जिनको हमने अक्ल दी है, जो साइंटिस्ट है। आम आदमी गौर नहीं करता इन चीज़ों के बारे में, सिर्फ वो लोग गौर करते हैं, वो लोग सोचते हैं, इसके बारे में फिक्र करते हैं। जिनको हमने अक्ल दी है वो इन चीज़ों के बारे में गौर करते रहते हैं, सोचते रहते हैं। सोचना, फिक्र करना, गौर करना, कुरान दावत देता है, बुलाता है लोगों को कि आओ हमारी इस बनाई हुई यूनिवर्स के अंदर तुम लोग सोचो कि हमने ये चीज़ क्यों बनाई, ये चीज़ हमने क्यों पैदा की। सोचने वालों को कुरान बहुत पसंद करता है, जो लोग सोचते हैं। लेकिन याद रखिएगा, सोच दो तरह की होती है, एक होती है पॉजिटिव थिंकिंग, एक होती है नेगेटिव थिंकिंग। पॉजिटिव थिंकिंग वो साइंटिस्ट जो दुनिया में कुछ अच्छा करने के बारे में सोचते रहते हैं कि दुनिया वालों को उसका फायदा पहुंचे, और नेगेटिव थिंकिंग वाले जो हैं वो ये सोचते हैं कि किस तरह हम दुनिया को बर्बाद कर दें, किस तरह हम दुनिया को तबाह कर दें, कोई ऐसा काम कर जाए दुनिया के अंदर कि दुनिया के अंदर बेचैनी फैल जाए। और जो सच्ची और सही सोच वाले लोग होते हैं, उनको अगर कभी उनके सामने कोई खराब चीज भी आ जाए तो वो भड़कते नहीं है। एक आखिरी मिसाल देकर मैं अपनी बात खत्म कर रहा हूँ। मैं एक किताब पढ़ रहा था, उसके अंदर स्वामी विवेकानंद के बारे में था। उनकी एक बात बहुत अच्छी लगी, जो मैं पढ़ी, वो मैं आपसे शेयर करके अपनी बात खत्म करूंगा। स्वामी जी के एक दोस्त थे क्रिश्चियन, उन्होंने उनके दिमाग का इम्तिहान लेने के लिए उनकी सोच कैसी स्वामी जी की, अपने घर पे बुलाया और अपने ड्राइंग रूम में उसने, उस क्रिश्चियन दोस्त ने एक मेज रखी और मेज पर बहुत सारी किताबें रख दी। सबसे नीचे रखी उसने गीता, उसके ऊपर दूसरी किताबें, उसके ऊपर दूसरी किताबें, और सब किताब, सारे मजहबों की किताबें ऊपर, और सबसे नीचे स्वामी जी की किताब। जब स्वामी जी अंदर आए तो स्वामी जी से कहने लगा वो क्रिश्चियन दोस्त उनका, स्वामी जी इस मेज में जो चीजें रखी हैं इसके बारे में आपका क्या ख्याल है? तो जो उन्होंने जवाब दिया वो आप सबके सुनने के लायक है। स्वामी जी कहने लगे, फाउंडेशन इज रियली गुड। ये मैंने बात इसलिए कही कि कड़वे हालात भी पेश आए आपको अपनी जिंदगी के अंदर, तो अगर आपकी सोच सही हुई तो आप हमेशा सही और सच्ची बात कहेंगे। शुक्रिया।
Thank you, Imam Sahab, for the spiritual guidance. So we now invite our Tarana team, Jamia Hamdard, for the melodious Hamdard Tarana. Give a big hand.
ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है। हम इसके चांद सितारे हैं, ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है। ताबीर है ये उस ख्वाब की जिस ख्वाब की मंजिल हिकमत है, जिस ख्वाब की मंजिल हिकमत है। ये शम्मा ऐसी शम्मा है जिसकी के जहां में शोहरत है, जिसकी के जहां में शोहरत है। इस वक्त जर्रे हैं हम सब पर तारे बनकर चमकेंगे, मानिंद गुलों के महकेंगे, महताब की सूरत चमकेंगे। ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है। पाई है यहाँ पर हमने जो दौलत वो लाफानी है, दौलत वो लाफानी है। हिकमत का पैगंबर था वो जो इस मेरे चमन का बानी है, इस मेरे चमन का बानी है। हर बात यहाँ पर हमने जो अखलाक मोहब्बत पाया है, हर सम जमाले इल्तिमा फूलों की तरह मुस्कुराया है। ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है, ये गहे हमदर्द है। नुसरत ज़फ़र का परचम हम इस आलम पर लहराएंगे, इस आलम पर लहराएंगे। इस रोशन शम्मा की खातिर हर तूफान से टकराएंगे, हर तूफान से टकराएंगे। सरसब्ज़ रहे शादाब रहे अल्लाह दुआ ये मेरी है। इस गुलशन पर ना आ जाए अल्लाह दुआ ये मेरी है। ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है, ये दर्स गहे हमदर्द है।
Thank you, Tarana team. Now I welcome Professor M.S. Alam, Head Department of Chemistry and the Seminar Chair, to formally welcome the guest.
Bismillahirrahmanirrahim. A very good morning to all of you. Distinguished guests on the dais, Janab Imran Hussain Sahab, Cabinet Minister, Civil Supply, Government of Delhi, and Chief Guest for today's function. Professor Afshar Alam Sahab, Honorable Vice Chancellor, Jamia Hamdard, and Patron of the seminar. Professor Faizan Ahmed Sahab, Guest of Honor. Professor R.K. Khandal, Keynote Speaker of the Day. Professor Sheikh Raisuddin, Dean, School of Chemical and Life Sciences. Dr. J. Christopher, Chairman ISAS JC. Professor G.S. Kapoor, Executive President IFDC. And Dr. Hina Hamid, Organizing Chair. It is with great pleasure and honor that I extend my warm welcome to each one of you at this international seminar on recent advancements in chemical and life sciences here at Jamia Hamdard. We are privileged to have the esteemed presence of Mr. Imran Hussain Sahab, Cabinet Minister of Civil Supply, Government of Delhi. His unwavering commitment to the promotion of science and technology is truly commendable. We are truly grateful to you, sir, that despite your busy schedule, you have spared your valuable time to grace the inaugural function. I am deeply grateful for the dedicated leadership of our esteemed Vice Chancellor, Professor Afshar Alam, who has consistently championed not only the advancement of science and technology, but also the comprehensive development of the university, propelling Jamia Hamdard to unprecedented achievements. It is under his visionary guidance that we have recently attained the prestigious A+ category accreditation reflecting the dedication and excellence that he has instilled within our institution. Thank you, sir. It is a particular delight to welcome our guest of honor, Professor Faizan Ahmed Sahab, a distinguished senior insect scientist. His outstanding contributions to the field of biochemical sciences have not only enriched our understanding but have also inspired numerous young scholars to pursue excellence in this domain. I have been fortunate to have shared his room during my short stint at Jamia Millia Islamia way back in 1989. We are truly fortunate to have you, sir, to grace today's occasion. I extend my heartfelt gratitude to Professor R.K. Khandal, the former director of Shriram Institute of Industrial Research, for graciously accepting my invitation to be the keynote speaker for this seminar. Having known Professor Khandal for over 25 years, I have personally witnessed the exceptional strides made under his visionary leadership at the Shriram Institute of Industrial Research. The institute not only achieved national prominence but also gained global recognition for its meticulously conducted high-quality research across various laboratories. Dr. Khandal's remarkable achievements were truly acknowledged by the government, notably when he was appointed as the Vice Chancellor of formerly Uttar Pradesh Technical University, widely known as UPTU, now renamed as Dr. Abdul Kalam Technical University at Lucknow. His transformative contribution to the advancement of both teaching and research served as a continuous source of inspiration for all of us. Once again, I express my sincere gratitude for your invaluable presence. The enthusiastic participation of over 150 delegates in this seminar is truly heartening. Your presence and engagements underline the significance of collaborative efforts in advancing science knowledge and fostering innovation. During this seminar, we aim to delve into the recent advancements in chemical and life sciences, hoping to uncover newer frontiers in research and discovery that can address some of the most pressing challenges of time. I urge each one of you to actively engage in the discussions, share your expertise, and foster meaningful collaborations that have the potential to shape the future of scientific research and innovation. I extend my best wishes to all the participants for a productive and enlightening experience throughout the course of this seminar. Let us seize this opportunity to deepen our
towards the bigger goal like bigger and sustainable development. Now I request Honorable Vice Chancellor Sir to kindly present the planter as token of gratitude towards our chief guest, Mr. Imran Hussain.
I
Sir.
began with the chief guest.
I request Honorable Vice Chancellor Jamia Hamdard to present the green planter to the keynote speaker. I request Vice Chancellor Sir to please present the planter to the guest of honor.
Thank you very much.
Guest of honor. Now I request Vice Chancellor Sir to please present the planter to the guest of honor. I request Dr. Christopher, Chairman, ISASDC, to present the planter to Honorable Vice Chancellor Sir. Now I request Professor. Now I request Professor M.S. Alam, Organizing Chair, to welcome Dean SCLS and Dr. Christopher with the planter. Now I request Dr. Hina Hamid to present the planter to G.S. Kapoor, Executive Chair. Then I request Professor G.S. Kapoor to present the planter to Professor M.S. Alam, who is the organizing chair. Then I request Dean SCLS to present the planter to Dr. Hina Hamid, who is the organizing chair. Everybody, please give it a big round of applause to whoever in the stage. I invite Dr. Christopher, Chairman ISASTC, to address the gathering and share his insight.
Chief guest of today's event, Mr. Imran Hussain, Minister of Food and Supply, Government of Delhi. Guest of honor, Professor Faizan Ahmed, INSA Senior Scientist. Honorable Vice Chancellor Jamia Ahmed, Professor Muhammad Afsar Alam. Keynote speaker, Professor R.K. Kandal, former Director, Sriram Institute of Industrial Research. Professor S. Raisuddin, Dean, School of Chemical Science. Dr. G.S. Kapoor, Executive Chairman, ISAS Delhi Chapter. Professor M.S. Alam, HOD Chemistry and Seminar Chair. Dr. Hina Hamid. Organizing Committee members, EC members of ISAS Delhi Chapter, invited speakers, oral and poster authors, delegates, students, and ladies and gentlemen. A very good morning to one and all. On behalf of ISAS Delhi Chapter, I welcome you all to this one-day international seminar on recent advancement in chemical science and life sciences, organized jointly by ISAS Delhi Chapter and Jamia Ahmad, New Delhi. ISAS Delhi Chapter is very glad and honored to be a part of this organizers of this seminar. Many of you are aware of ISAS Delhi Chapter and its activities. However, for the benefit of new delegates and participants, I would like to give you a brief about the ISAS Delhi Chapter. ISAS Delhi Chapter was established in 1992 to promote the growth of analytical science in the northern parts of the country. The headquarters of ISAS Delhi Chapter is Indian Oil R&D Center, Faridabad. Among the 13 chapters of ISAS all over India, ISAS Delhi Chapter is the most active chapter. Delhi, etc. Based on the activities and contribution to the analytical science in northern parts of the country, ISAS Delhi Chapter was adjudged as the best chapter by the parent body 4 times in the past. This chapter also provides partial finance assistance of rupees 25,000 rupees to students to present research work in international conferences abroad. We have introduced new schemes like Lifetime Achievement Award and Young Researchers Award last year, and the awardees will be felicitated in the GBM today at Hotel Sevagrant, Badarpur Border, Delhi. I invite all the live members to attend the GBM followed by dinner at 7 p.m. today. We are also planning to introduce Merit Cum Means Scholarship of rupees 18,000 rupees per month per year for the students from the poor background. ISAS Delhi Chapter is now an established scientific forum with sound financial and intellectual backing. I invite the delegates, faculties, and students to become member of this active society. Live membership fee is only 1,500 rupees. For more details, please visit our website www.isasdelhi.org. Coming back to the seminar, I hope the lectures by the eminent speakers will address the theme of the seminar, that is recent advancement in chemical and life sciences. I anticipate useful and effective interaction by the participants with the experts. Once again, I welcome all of you for the seminar and wish the seminar a grand success. Thank you.
Thank you for your valuable insights, sir. Now I request Dean SCLS, Professor S. Ray Siri, to kindly say a few words, sir.
Big hand to the dean.
Assalamu alaikum. A very good morning. Honorable Vice Chancellor Jamia Hamdard, Honorable Minister Imran Hussain Sahab, Minister of Food and Supply, Government of India, dignitaries on the dais and off the dais, many people have come. So I welcome on my behalf and on behalf of the School of Chemical and Life Sciences to this international seminar on the recent advancements in chemical and life sciences, organized jointly by the Department of Chemistry, our school, and Indian Society of Analytical Scientists, Delhi chapter. So this conference, I saw the lectures have been very well designed. We have many speakers from industry, also from academia, persons like Dr. Kandal, who has vast experience of industry, academic, and mixed experience. Professor Faizan, a very renowned biochemist, protein chemist, and we are honored to have here Professor Faizan as honorary scientist in INSA, and all the members, executive member, president, chairman of the society. This conference is focused on the chemical and life sciences. You know that in spite of invention of the artificial intelligence, the importance and relevance of life sciences has increased manifold, because people thought that AI will take up the other kind of technologies and sciences. But without biology, without inputting biological data, biological information to the AI, very difficult that AI system will work. So life sciences as well as chemical sciences will remain relevant, and it will explore new frontiers. I hope in this seminar these kind of aspects will be discussed, and I welcome again to the campus. I also visit different laboratories. Our school and chemical and life sciences school has 6 departments, including very important department of chemistry, botany, biotechnology, and toxicology even. You will find very rarely that toxicology and chemistry department are existing together in order to see and study the effects of chemicals on, including food chemicals on the biological system. And we have biotechnology department. We have also a biochemistry department, and also clinical research and translation research department is there. So very, very selective, focused departments are there in the school. And besides, we have pharmacy, which is #1 in India for last 4 years, and today in this cycle it was second to number, but very, very, very slight difference between first and 2 rankings. So this has been possible because of the dynamic leadership of our Vice Chancellor, who is at the helm of affairs for more than 2 years and has been guiding us for different types of activities, excellence, rankings, accreditation, all sides of achievements Jamia has made in 2 years is because of the visionary leadership of our Vice Chancellor. And he has been inviting eminent people to the campus, like we have today Mr. Imran Hussain Sahab, who is very dynamic young minister of our state, Delhi, and he is keenly involved looking into our development. Sir, we are very much grateful to you for visiting our campus and also our school. So with these words, I again welcome all the members, all the delegates to the seminar. Thank you very much.
Thank you, sir, for the kind words and encouraging our delegates. Now we have the privilege of hearing our guest of honor, Professor Dr. Faizan Ahmed, who is a distinguished scholar, holds a background in chemistry and biophysical chemistry, enriched in extensive postdoctoral assignments in North America especially. He has received accolades such as Fellowship from Indian Sciences Academy and National Academy of Science, along with the Pride of Delhi Award during his tenure at Jamia Millia Islamia. Throughout his career, he made a substantial contribution to research and academia, serving at various leadership roles at the institution. Professor Ahmed's primary research revolves around the protein folding problem with a particular focus on protein stability, determination, and folding intermediates. He has guided more than 50 PhD students and authored over 330 research papers showcasing his profound impact in the field. I may now request Professor Faizan Ahmed Sahib to kindly address the gathering.
Thank you very much for your kind words. Honorable Mr. Sahib, Imran Khan Sahib, Vice Chancellor Sahib, dear colleagues sitting on the dais and colleagues sitting in front of the dais, ladies and gentlemen, may peace be upon you all. When I got invitation, it was a telephonic invitation to be part of this inaugural event. I immediately looked at my calendar and accepted it. The reason for this was that I felt honored and thrilled to accept this invitation and to be part of this academic event. Then a question popped into my mind, why me? Then I realized that probably these organizers have gone through my biodata and found that I have been trained as a chemist. And during my MSc training, I realized that at least for me, chemistry will be more interesting if I apply this chemistry knowledge to understand the biological problem. And that's why I went to a biochemistry department and started doing work in that area. So I'm really very happy to be participant to this inaugural function of this conference organized by the Department of Chemistry. And I have gone through the talks and found that there are very interesting lined up very interesting talks talking about various aspects of life sciences looked from the glasses of a chemist. In the end, I would like to say thank you, a very big thank you to the organizers for having me here. I'm really honored. Thank you very much.
Thank you, sir, for encouraging our delegates. We are grateful for the presence of Janab Imran Hussain Sahib.
Give a big hand to the
He is a dedicated politician and Delhi Cabinet Minister for Food Supply and Election and is known for his humble beginning in the walled city area of Delhi. He's actively worked in the social and political awareness among the underprivileged people. Now I request sir to kindly say a few words.
अस्सलाम वालेकुम। स्टेज पर तशरीफ फरमा जामिया हमदर्द के वाइस चांसलर प्रोफेसर अफशार आलम साहब, गेस्ट ऑफ ऑनर जनाब प्रोफेसर फैजान अहमद साहब, कीनोट स्पीकर जनाब प्रोफेसर आर के खंडल साहब, डीन SCLS जनाब प्रोफेसर रईसुद्दीन साहब, Executive Chairman Dr. G.S. Kapoor Ji, Chairman ISAS DC Dr. J. Christopher, Seminar Chair or HOD Chemistry Professor M.S. Alam Sahab, Organizing Chair Mohtarma Dr. Hina Hamid Sahiba, distinguished guests, esteemed colleagues and enthusiastic delegates. It is my great honor and privilege to address the esteemed gathering at the international seminar on recent advancement in chemical and life sciences. I extend my heartfelt gratitude to Jamia Hamdard for hosting his significant event and providing a platform for the exchange of groundbreaking ideas and research in the realm of science. I am deeply humbled to be in the presence of luminaries such as Professor Faizan Ahmed Sahab, whose contribution to the field of science have been nothing short of extraordinary. Your dedication to the advancement of scientific knowledge is truly commendable, and your presence here today only adds to the significance of this gathering. I would be remiss if I did not acknowledge the keynote speaker, Professor R.K. Khandal, whose illustrious career has undoubtedly shaped the trajectory of industrial research, especially his role in shaping Shri Ram Institute of Industrial Research to newer heights. His insightful contributions have not only propelled the boundaries of scientific discovery but have also inspired countless young minds to pursue excellence in the field of chemical and life sciences. This seminar, attended by over 150 distinguished delegates, serves as a testament to our collective commitment to furthering scientific understanding and fostering innovation. The discussion and deliberation that will take place here over the course of the seminar hold the potential to unlock new avenues for scientific progress and pave the way for transformative discoveries that can address some of the most pressing challenges of our time. The theme of this seminar, recent advancement in chemical and life sciences, encapsulates the spirit of innovation and collaboration that is integral to our pursuit of scientific excellence. As we delve into the intricacies of this theme, I encourage each one of you to actively engage in constructive dialogue, share your valuable insights, and cultivate partnerships that transcend geographically boundaries and disciplinary constraints. I have no doubts that the outcomes of this seminar will not only enrich our understandings of the complexities of the natural world but also inspire us to push the boundaries of scientific knowledge further in service of the greater good. I wish you all a fruitful and enriching experience at this seminar. Let us embrace the opportunity to foster meaningful collaborations and chart a course towards a future where the impact of our collective efforts resonates for generations to come. शुक्रिया, जय हिंद, अस्सलाम वालेकुम।
Thank you, sir. Thank you for being a beacon of inspiration for our young delegates. We now invite our Honorable Vice Chancellor, Professor Dr. Muhammad Afshar Alam Saab, who has always been instrumental in promoting science and technology activities in Jamia Hamdard. Professor Afshar Alam Saab has assumed the charge of the Vice Chancellor of Jamia Hamdard in 2021. So he is the first internal professor from Jamia Hamdard to have been elevated to the position of the Vice Chancellor. We are all very much proud of you, sir. So he did his master's in MCA from Aligarh Muslim University and PhD from Jamia Millia Islamia. He is the founder of Computer Center, Department of Computer Science in Jamia Hamdard. He has served Jamia Hamdard in various capacities, including HOD, Dean, and foreign student advisor and finance officer, and what not. Everywhere he has contributed immensely to the university. So his research areas include software re-engineering, data mining, bioinformatics, fuzzy databases, and sustainable development. He is the founding member of the computer-wide networking at Jamia Hamdard. Now I will request sir to address the gathering.
Thank you.
Thank you very much. Good morning. Janab Imran Hussain Saab, the Honorable Cabinet Minister of Food, Civil Supplies, Consumer Affairs and Election, Government of Delhi NCT. Professor Faizan Ahmed Saab, the Senior INSA Scientist. Professor R.K. Kandar, former Director, Sri Ram Institute of Industrial Research and former Vice Chancellor of UP Technical University. Professor Raisuddin Saab, the Dean, School of Chemical and Life Sciences. Professor Sarwar Alam Saab, the HOD and Program Chair of the today's international seminar. Professor J. Christopher, Chairman ISAS DC. Professor J.S. Kapoor and Dr. Hena Hamid and all the deans and HOD of different departments and schools. I stand here before you today to celebrate the remarkable advancement in the field of chemical and life sciences. You all know that our great nation, India, has always been at the forefront of innovation and discovery, and recent years, our researchers, scientists, institutions are continuing to push the boundaries of knowledge, yielding existing breakthroughs. The reason of the chemical sciences we have witnessed for the momentous achievement in the field of material science, in the field of chemical science, biomedical science, and sustainable energy resource. Our commitment to addressing the climate change has led to the development of cutting-edge technologies, from more efficient solar cell to the novel energy storage solutions. These innovations not only reduce our carbon footprint, but also offer to promise a cleaner and greener future. Life sciences have also made extraordinary progress. Our scientists and researchers have unlocked the mystery of the human genome, leading to the groundbreaking advancements in the personalized medicine. With the genomics and proteomics and precise therapies, we are transforming the way we treat the disease, offering targeted solutions that promise better health and improve quality of life for all. Furthermore, in the midst of the global pandemic, our life science experts mobilized to develop a vaccine at an unprecedented pace. The rapid development of these vaccines so-called the power of scientific collaboration, paving the way of global recovery and reminding us of the importance of science in our lives. Let us not forget the critical work being done in bioengineering, which is also revolutionizing the possibility of regenerative medicine, artificial organs, and even the prospect of life beyond Earth. As a nation, and even as our university, we are investing in research and education to ensure that we remain the leaders of this field. We must continue to support our scientists and foster and the environment of curiosity and innovation. Together, we can harness the potential of chemical and life sciences to address the challenges of our time and create a brighter, healthier, and more sustainable future for all. Thank you, and let us remain committed to pursue our knowledge and progress. Thank you very much.
Thank you, sir, for your motivation, and we are thanking you for your able leadership which is helping Jamia Hamdard to flourish further and further. So I am pleased to introduce Dr. Rakesh Kumar Khandal Saab for the keynote lecture. So the keynote address is in coherence with the theme of the seminar, and we are fortunate that none other than Professor Dr. Rakesh Kumar Khandal is here to share his enriched experience. He is a distinguished academician and industry leader known for his significant roles in research and development. He has held prominent positions in India Glycols Limited, and Vice Chancellor Uttar Pradesh Technical University. Now it has been renamed as Abdul Kalam Technical University, and the Director Sri Ram Institute for Industrial Research. With a rich academic background, numerous patents and research papers, he has made substantial contributions to his field. His involvement in high-level government committees and presidency of WAITRO, a UN body, underline his global impact. Dr. Khandal's achievements are recognized through a plethora of awards, showcasing his commitment to innovation and sustainability. So we and the delegates are eagerly anticipating the wisdom and knowledge that you will impart, sir. So kindly take the podium.
Thank you very much. Thank you very much. श्रद्धेय मंत्री जी, दिल्ली सरकार के इमराज हुसैन जी, बहुत बहुत धन्यवाद, प्रणाम करता हूं आपको। और आपके साथ डैश शेयर करके मुझे बहुत आनंद आ रहा है, आनंद की अनुभूति हो रही है। आपका भाषण सुना और भी अच्छा लगा। जैसा आपका पर्सनैलिटी ऑरा है, वैसा ही आपका भाषण। बहुत बहुत धन्यवाद। परम आदरणीय चांसलर ऑफ दिस यूनिवर्सिटी, ग्रेट यूनिवर्सिटी, kindly Professor Alam convey my regards to him. You know, visionaries like him are born once in centuries, and that is how this university has been set up by him. We are all grateful to him, and I am personally very grateful to him. For the reason that I feel that in my last birth I was associated with Jamia Hamdard University. Would you believe it that it is almost about 25 years ago, I was the one as a director Shri Ram Institute signed the MOU with Jamia Hamdard University. And hundreds, maybe thousands of your students must have taken training in Shri Ram Institute during my tenure when I was as a director for almost about 12 years. और आपके यहाँ बहुत सुंदर मैडम थी, सरवर सुल्ताना, मैं उनका बहुत बड़ा फैन था। और जब पहली बार मैं उनसे मिला तो मैंने इमीडिएटली MOU साइन कर दिया कि जामिया हमदर्द के साथ MOU साइन। और फिर ईश्वर की कृपा ऐसी रही कि अभी हिना मैडम कौन सी कम है। तो आप देखिए, मैं बहुत भाग्यशाली हूँ वाइस चांसलर जी, मैं बहुत भाग्यशाली हूँ कि हिना मैडम के साथ संपर्क रहा आदरणीय प्रोफेसर सरवर आलम जी के कारण। प्रोफेसर सरवर आलम जी और हम दोनों पिछले जन्म में एक साथ थे, इस जन्म में थोड़ा लेट मिले। तो ऑलमोस्ट लाइक 10 of my students have done PhD. I think 8 or 10 students did PhD here with Professor Sarwar Alam as the guide from the university, and I happen to be the guide from outside the university. आपके अर्लियर वाइस चांसलर प्रोफेसर काजी जी के साथ मेरा बहुत घनिष्ठ संबंध है, और आज आपके जो प्रेजेंट वाइस चांसलर इनके साथ भी इतना गहरा गाढ़ा संबंध हो गया। इतने पुण्य आत्मा हैं, थैंक यू वेरी मच। आपके साथ फोटो भी हो गए मेरे बहुत सारे। और आप देखिए कितनी विचित्र और कितनी अद्भुत बात है, सब कुछ पूर्व निर्धारित होता है जीवन में। मैंने झारखंड में पढ़ाई की, PhD इंडियन स्कूल ऑफ माइंस धनबाद से की, और आपका भी झारखंड से बहुत पुराना संबंध है और बचपन में झारखंड में रहे हैं। तो मुझे बहुत अच्छा लग रहा है जामिया हमदर्द यूनिवर्सिटी में आफ्टर ए लॉन्ग टाइम टू कम बैक अगेन। थैंक यू वेरी मच हिना मैडम, थैंक यू वेरी मच सरवर आलम जी। मैं आदरणीय प्रोफेसर सरवर आलम जी को नमन करते हुए धन्यवाद देता हूँ प्रोफेसर रईसुद्दीन जी का भी। इनसे जब भी मिलता हूँ तो एकदम खिल जाता हूँ। He is so jovial and jolly, and in every complicated matter, complex matter of chemistry and sciences, यू वुड ऑलवेज फाइंड, सच बता रहा हूँ, आपको लग रहा होगा विचित्र, बिल्कुल सही बता रहा हूँ। और इनके साथ एकदम किसी को हीमोग्लोबिन कम हो तो वो रईसुद्दीन जी से मिल लीजिए, हीमोग्लोबिन बढ़ा देंगे। किसी को टेंशन हो रहा हो तो उसका टेंशन भी कम कर देंगे। तो टुडे इज अ ग्रेट अपॉर्चुनिटी फॉर मी ऑल्सो टू हैव मेट प्रोफेसर कपूर एंड प्रोफेसर डॉक्टर क्रिस्टोफर। आईओसी के साथ भी मेरा बहुत अच्छा संबंध रहा है। कई बार जब वहाँ मैं जाता था एज इनवाइटेड लेक्चर भाषण देता था, और आईओसी के साथ बहुत सारे कोलैबोरेटिव रिसर्च प्रोजेक्ट्स किए, और आप सबके साथ भी मेरा बहुत गहरा संबंध है। कार्यक्रम प्रारंभ होने से पहले मैं बहुत प्रभावित हुआ। कुरान की जो पवित्र पंक्तियां सुनाई गई वो मेरे हृदय को टच कर गई। और सर आपने इतना अच्छे से एक्सप्लेन किया, इससे अच्छा कोई एक्सप्लेन नहीं कर सकता। मैं स्वयं एक बात मानता हूँ और स्वयं ये बात कहता हूँ, और उसको मैं रिपीट करता हूँ आज, जैसा भाव वैसा प्रभाव। आपने कहा जल वही है, जल वही है, भूमि वही है, वही करेला होता है, वही नीम होता है, उसी में पीपल होता है। और सबसे बड़ी बात ये कि नीम के ऊपर चढ़ा हुआ करेला और भी स्पेशल करेला होता है, मुहावरा भी है, करेला और नीम पे चढ़ा हुआ, और जल एक ही है। तो कितना भाव है वैसा प्रभाव है। बहुत सुंदर आपका कुलगीत, और मैं ये कुलगीत चाहूंगा कि इसको हिंदी में और संस्कृत में भी ट्रांसलेशन हो। मैं तो देखिए, मैं सबसे अधिक प्रभावित था बीएचयू के कुलगीत से। वाइस चांसलर रहा हूँ, यूपी टेक्निकल यूनिवर्सिटी का भी अपना एक बहुत अच्छा कुलगीत था। कुलगीत, कोई भी कुलगीत विश्वविद्यालय का परिचायक होता है, विश्वविद्यालय का एक स्टेटस और स्टैचर को रिप्रेजेंट करता है। तो आपका कुलगीत वास्तव में बहुत फ्लोरिंग है, और मैं इसके ऊपर लिखूंगा भी, और मैं बहुत प्रभावित हुआ। और आपका जो विवेकानंद जी की जो आपने बताई ना बात, वो बहुत फंडामेंटल है जीवन का। हम छोटी छोटी बातों पे विचलित हो जाते हैं, छोटी छोटी बातों पे अपसेट हो जाते हैं और उत्तेजित हो जाते हैं, और वो छोटी बातें यदि हम इग्नोर कर दें तो हम प्रसन्न रहते हैं। मिनिस्टर हैज टू गो, तो मैं जल्दी करता हूँ। मंत्री जी, मैं बड़ा उपयोगी प्राणी हूँ, और आप, हाँ पता है, मंत्रियों के पास कहाँ समय होता है। देखिए, आए भी वो समय से और जाएंगे भी समय से, कहाँ समय होता है उनके पास। तो मंत्री जी, ये जो भाषण है ये बहुत अच्छा है, और दिल्ली की जो AQI की समस्या है उसको सॉल्व करने के लिए ये भाषण बनाया मैंने। देखिए मैं अभी, मंत्री जी कह रहे थे आप आइए, मैंने कहा बिना बुलाए तो मैं ऊपर वाले के यहाँ भी नहीं जाऊंगा। जब वो 4 भेजेगा तब जाऊंगा। तो ये भाषण मैंने, देखिए, बहुत सीरियस है, और इसको आप प्लीज सीरियसली लेंगे, बिकॉज आपके चक्षु खोलने के लिए ये भाषण बनाया मैंने। और ऐसे भाषण नॉर्मली प्रोफेसर्स देते नहीं, क्योंकि ऐसे भाषण ना तो इनके ऊपर बुक्स हैं, ना इनके ऊपर ज्ञान ऐसा शेयर किया जाता है। एंड आई एम वेरी फॉर्चुनेट बिकॉज आई हैव वर्कड इन इंडस्ट्री, एंड माय लर्निंग ऑफ केमिस्ट्री एंड केमिकल इंजीनियरिंग एंड मटेरियल साइंस has been by practice from the industry. I started my career as a teacher, very young, in Indian School of Mines, Dhanbad, at a very young age. Then went to various institutions, public sector, private sector, autonomous body, went to industry, went to university. तो पूरा इतना सारा मेरे साथ मसाला है मेरे पास, तो इसलिए मैं कहता हूँ आई एम वेरी उपयोगी, यूज मी। जैसे वो डस्टबिन पे लिखा रहता है ना, यूज मी, ऐसे मैं बोलता हूँ आई एम वेरी यूजफुल, यूज मी। सो दिस प्रेजेंटेशन बेसिकली, तो सरवर आलम जी, बहुत जल्दी करता हूँ, फटाफट करता हूँ, अब चिंता, आनंद आएगा। सो बेसिकली आई विल बिगिन विद इवोल्यूशन ऑफ केमिकल साइंसेस। बेसिकली सेमिनार का जो टॉपिक है वो है एडवांसेस इन केमिकल साइंसेस एंड बायोलॉजिकल साइंसेस। टुडे बोथ ऑफ देम ऑलमोस्ट हैव मर्ज्ड इनटू ईच अदर. You can't separate chemical sciences from biological sciences. I will start with evolution. I will talk about how the advances have taken place in chemical sciences. And you will find that starting from where we were thousands of years ago, we have come back to square one today as far as the advancement is concerned. And I will show it to you. I will tell you how the advances in the form of raw material, how the advances in the form of processes and product related aspects I will cover. Then I will talk about the trends in the chemical industry today, how the chemical industry looks like and how it will be in times to come. So I'll present to you the path forward. It is very important for research scholars of today who are working in chemical sciences and biological sciences to pay attention to what I'm saying. My dear friends, beyond BC, 1000 BC, you know, in this country, India is the only, in fact, it's not a country, ये राष्ट्र है, ये यूनिक है, ये सभ्यता है, civilization है. केमिकल साइंसेस के गुरु हैं हम लोग. हमारे पूर्वज ऋषि मुनि और ब्रह्म ऋषि थे, और उनको केमिकल साइंसेस का कितना ज्ञान था वो मैं आपको बताता हूं विद एग्जांपल्स एंड विद perfect actual happening what had happened. So you discovery of extracting metals. You know, when we start our education, we are taught periodic table and we get excited in 9th standard, 10th standard periodic table, badi discovery ho gayi. Our forefathers knew each and every aspect of it thousands of years ago. Extracting metals, pottery, glazes, fermenting beer and wine, extracting chemicals from plants, medicine and perfume, and soap, making glass, making alloys like bronze. We were the first to do it. We had Rasvidya, we had Rastantra, and we had Raskriya. Rasvidya is science, Rastantra is technology, and Raskriya is innovation. So science, technology, and innovation about chemicals was very much there in India thousands of years ago. In Vedic period, this is very important, please listen. In Vedic period, all the matter, all the materials were derived based on 9 basic characteristics. First characteristic, earth. You know, any matter you do, when you do reverse engineering, when you do, decoding, when you find out what this material is, you always find percentage solids. You always do. Find out the percentage solids, that is earth. You find air, that is the space there in it. So you do the density, bulk density, compact density. You find the density in different liquids. You do density gradient. You know how the density gradient is used for separation of minerals. Then space, how much space it will occupy. So crystallography, water, moisture content, inherent moisture, associated moisture, various forms of. Then ether, that is vapor, vapor pressure, vaporization. Self, atma, pratyek material ki atma, what is its nature, how it is going to be like. Fire, tejas, how much tej is there in it. That means reactivity, how reactive the material is when you prepare the material safety data sheet. There are so many components, all of them were known already in the Vedic science. Time, with time, how it will change, transform. And manas, how it will transform with its own activity. That is, these days we call it as artificial intelligence. Post-Vedic period, we had various kinds of shastras. All of them talked about chemical sciences. I will mention Acharya Nagarjuna. In his life, he spent almost about 12 years of fundamental research on chemical sciences. And he discovered the alchemy of transmuting base metals into gold. He could convert base metals into gold. And he knew that technology. Author of medical books like Arogya Manjari, Yoga Sar, these were the scientists of the past in India. Unfortunately, we have forgotten, but now we are remembering. Those who are doing the new developments, they are referring to Nagarjuna's concept. This is very important, Panch Mahabhut concept. In chemical sciences, if you understand Panch Mahabhut concept, you will be able to understand everything. COVID-19 has taught us so many things. All of us who are sitting here are divided into 3 categories. There are people who are Vat, there are people who are Pitta, and there are people who are Kaph. For example, I am Kaph Pravritti. हमारे मंत्री जी कफ प्रवृत्ति के हैं, हमारे वाइस चांसलर जी भी कफ प्रवृत्ति के हैं. ओके, ऑलमोस्ट सर्वर आलम जी पित्त प्रवृत्ति के हैं. तो पित्त, कफ और वात, दिस इज बिकॉज ऑफ द 5 बेसिक एलिमेंट्स दैट वी आर मेड अप ऑफ. 5 तत्व से सब कुछ बना है, 5 तत्व से. और it is a fundamental saying that yatha pinde tatha brahmande. And when scientists did the research, the chemical scientists don't believe unless they have the proof. There are 104 elements in the periodic table. They said if yatha pinde tatha brahmande, then we should have all the 104 elements existing in our human body. So they did the analysis of human body, and they could detect almost like close to 90 elements. The rest they could not, because we don't have instruments yet to go to, you know, Christopher Saab knows it because it's the Conference of Analytical Sciences. You know, if it is below the detection limit, you won't be able to find out. But at least they have been able to find out close to 80 to 90 elements. So this Panch Mahabhut concept is fundamental for everything that has happened in chemical sciences and biological sciences. But we have not been taught the way it was earlier, because all our libraries were burnt, all our knowledge was burnt, and we were busy into surviving ourselves, so we have lost that knowledge. But it is time everybody is talking about it. This is a picture I think all young students, research scholars must know this. In the year 1700, we were number 1 in GDP in the world. It was not long ago, only 320 years ago. And we are reaching to 5th place. Yesterday, I was reading the economic survey of the world, and I was told that the Germany has replaced Japan. Okay, Germany has gone to number 3rd, Japan has come to number 4th, and India is still at 5th. And all of us, if we prepare with the advancement of science and biological sciences, we can be number 1 very soon. मैं एक दो एग्जाम्पल भी देता हूं कैसे हो सकते हैं. इमेजिन 130 करोड़ भारतीय. सर आपने अभी कुरान का भी बताया, विवेकानंद जी का भी बताया. हम सब लोग एक निर्णय ले लें, बच्चों को भी बताएं कि आप रोगी नहीं होंगे. इमेजिन मंत्री जी, आप ये देखो, अगर 130 करोड़ भारतीय ये डिसाइड कर लें कि हम रोगी नहीं होंगे, क्योंकि ये तो हमारे ऊपर है, हमारे हाथ में. इस शरीर में रोग पैदा करने की विधा है, तो रोगों के निवारण की भी विधा है. यदि 130 करोड़, अब लोग हंस रहे हैं कि ऐसा थोड़ी होता है, बीमार तो पड़ेंगे, इतने बड़े बड़े हॉस्पिटल है वो कैसे चलेंगे, इतने सारे डॉक्टर हैं वो कैसे चलेंगे. मैं उनसे कहता हूं कि आप थोड़ी, जरूरी है आप जाओ, वर्ल्ड के सारे रोगियों को बुलाओ, उनको डिस्काउंट पे ट्रीटमेंट दो, सारी मेडिसिन से एक्सपोर्ट करो. आपका $1 का 80 रुपया होता है ना, आप देखना कि $1 का $80 हो जाएगा यदि आप सब लोग निरोग रहोगे. और निरोगी होना हमारे हाथ में. मैं अभी मंत्री जी को कह रहा था कि मंत्री जी आप रात्रि का भोजन मत किया करो, क्योंकि हमारे शास्त्रों में कहा है कि सूर्य देवता के सामने टॉयलेट नहीं करना और चंद्र देवता के सामने भोजन नहीं करना. तो लोग पता है क्या करते हैं, लोग ये करते हैं कि ईस्ट फेसिंग टॉयलेट नहीं बनवाते ताकि सूर्य देवता के सामने ना करना पड़े, वेस्ट फेसिंग बना लेते हैं और जा रहे हैं टॉयलेट 8 बजे के बाद, उठ ही रहे हैं 8 बजे. ये एडवांसमेंट ऑफ केमिकल साइंसेज एंड बायोलॉजिकल साइंस का मोस्ट इंपॉर्टेंट एस्पेक्ट है, जो पिछली स्लाइड पंचमहाभूत की और ये वाली स्लाइड जो इकोनॉमी की. Soon we will be crossing all of them, provided we all decide. You know, zinc extraction. Zinc is a very precious metal. This extraction we knew thousands of years ago. और कैसे बनाते थे? जैवर माइन है राजस्थान में, और वो 2 कढ़ाइयों से जिंक सेपरेट करते थे. जब अंग्रेजों और चाइनीज ने पहली बार देखा, आज आप गूगल पे सर्च करना, एक्सट्रैक्शन ऑफ जिंक फ्रॉम दी ओर एंड मिनरल्स, एक कढ़ाई नीचे और एक कढ़ाई उल्टी ऊपर और नीचे पानी. दिस इज हाउ दे यूज्ड टू डू. तो अंग्रेजों ने यहां से टेक्नोलॉजी ली, वो चाइनीज के पास गई, चाइनीज ने ली, चाइनीज से अंग्रेजों के पास गई, या वट एवर इट इज. आप देखना अल्टीमेटली जिंक कैसे निकालते हैं वो हमने बताया. हमारे शास्त्रों में जिंक और निकल दोनों निकालने का था. अच्छा, भारत में एक डाई होती थी इंडिगो. इंडिगो डाई को ब्लू गोल्ड बोलते थे. मतलब भोजन भी सस्ता था उसके सामने, डॉलर्स में बिकती थी वो. और अंग्रेज भारत में आए इसीलिए कि उनको इंडिगो डाई चाहिए थी. एक स्थिति ऐसी आई थी कि उन्होंने फोर्स किया फार्मर्स को, बंगाल, बिहार, तमिलनाडु, फोर्स किया कि आप केवल इंडिगो बोओगे, और वो इंडिगो इंग्लैंड ले जाते थे. इंटरेस्टिंग, उनको पता था इंडिगो बेस्ट डाई है, वो लोग जीन्स बनाते थे. लेकिन जब वो हमारे यहां से डाई ले गए, वो डाई नहीं कर पाए. बिल्कुल देखिए, जहां भगवान ने ना भूमि के नीचे जिसको दे दिया, उसको भूमि के ऊपर नहीं दिया. जैसे पूरा मिडिल गल्फ, पूरा पेट्रोल दे दिया, ऊपर से गायब कर दिया. हमारे यहाँ नीचे नहीं दिया, ऊपर दे दिया. तो जितने गल्फ के रिफाइनरीज और ये सब इंडियंस चलाते। आप चले जाइए, आप देख लीजिए, पूरा नाइजीरिया की रिफाइनरीज भी आपको इंडियन मिल जाएंगे। वहां पूरा वेस्ट इंडीज में पूरा त्रिनिदाद टोबैगो और वो गयाना, उधर जो रिफाइनरीज है वो सब इंडियंस चलाते हैं। तो इंडिगो वो यूज ही नहीं कर पाए। फिर इंडियंस वो दे केम टू तिरुपुर इरोड, तमिलनाडु में आके उन्होंने देखा कि कैसे डाई करते हैं, बिकॉज इंडियंस ने डाई ही नहीं निकाली। ये केमिकल साइंसेस का एडवांसमेंट था, उन्होंने डाई ही नहीं निकाली। डाई कैसे करना है उसका प्रोसेस भी डेवलप किया, उनको सिखाया और फिर गया। जब से उस जर्मन ने इंडिगो का सिंथेटिक रूप निकाला, सरवर आलम जी, जिस दिन से वो निकाला, इंडिगो का रेट डाउन हो गया। और अब क्या हो रहा है? अब ये हो रहा है कि सब लोग कहते हैं इंडिगो चाहिए। अब पुनः, दैट इज व्हाट आई सेड, वी आर बैक टू स्क्वायर वन। आई रिमेंबर, I come from the industry. About 40 years ago, India did not have the technology of dyes and colors. And there was a company called ICI. Name of the company was Imperial Chemical Industries. I was manager in Imperial Chemical Industry in India. Also, I worked in ICI UK. Okay? They had the technology of dyes and colors. They did not want to share it with anybody. सारे Indian industrialists बोलते थे हमको टेक्नोलॉजी दे दो, नहीं देते थे। One day, one Swiss scientist, a German scientist, told them that dyes and colors will spoil the weather and climate and environment of Europe. So they said, क्या होगा भविष्य में? बोले जल्दी से इस टेक्नोलॉजी को बाहर निकालो। उन्होंने टेक्नोलॉजी इंडिया को दी, अपने आप दी, और दिखाया है कि हम टेक्नोलॉजी दे रहे हैं। और वो प्लांट लगा अतुल वलसाड़ में, गुजरात में। बहुत सुंदर जगह है अतुल। जो लोग केमिकल साइंसेस पे रिसर्च कर रहे हैं, दे मस्ट विजिट, एटलीस्ट गूगल पे विजिट करें। और वहाँ बहुत अच्छे चीकू और बहुत अच्छे आम होते हैं अतुल में। इतना बड़ा प्लांट लगाया, अमेरिकन साइनामाइड का प्लांट लगा, अतुल इंडस्ट्रीज लगा, उस स्टेशन का नाम ही अतुल है। और वहां पे उन्होंने डाइज एंड कलर्स का लगाया। और ब्यूटी देखिए मंत्री जी, डाइज की टेक्नोलॉजी दे दी और रेस्ट्रिक्शन लगा दिया कि यहां से टेक्सटाइल यदि उस डाई से डाई होके आया तो वो रिजेक्ट हो जाए। कैन यू इमेजिन? ये केमिकल साइंस का एडवांसमेंट है या बैकवर्डनेस है, ये आप डिसाइड करिए। अब एडवांसेस रॉ मटेरियल, यू नो, आज प्रत्येक व्यक्ति कह रहा है डीकार्बोनाइज, कार्बन फुटप्रिंट। ओके, हमने हमारी रिसर्च स्टार्ट हुई कोल से हम सिनगैस पे आए, सिनगैस से एसिटल, अमोनिया, डीएमई, मिथेनॉल, सिटी गैस, लिक्विड्स, ऑल दैट। देन सॉल्ट एंड लाइमस्टोन से पूरे क्लोरिनेटेड कंपाउंड्स आए हमारा। जैसे मान लीजिए ईडीसी आया, वीसीएम आया, पीवीसी आया, एमडीआई, टीडीआई, क्लोरोइथेन, क्लोरोमीथेन, ये सारे केमिकल्स आए फ्रॉम द सॉल्ट एंड लाइम बिकॉज वी प्रोड्यूस क्लोरीन। इंडिया में भी प्लांट होते थे जो इस प्रोसेस, इस रॉ मटेरियल को यूज करके होते थे। These were called advancements. In my opinion, they were worst for us. Then came crude oil. From crude oil, we had the naphtha and gas oil, and from there we had aromatic reforming technology, FCC unit, and then the steam cracker, and that gave us thousands of chemicals. आप ऑर्गेनिक केमिस्ट्री की बुक पढ़िए, आप देखेंगे इतना सारा केमिकल्स हैं, यू विल गो मैड। इनफैक्ट यंग बच्चे पढ़ते ही नहीं अब केमिस्ट्री, वो कहते हैं इससे अच्छा तो बीबीए कर लो, एमबीए कर लो, और अच्छा पैकेज मिल जाता है, कहाँ केमिस्ट्री में जाना। तो ये केमिकल साइंसेस के एडवांसमेंट बता रहा हूँ आपको, विच हैज लेफ्ट इम्पैक्ट ऑन द देन नेचुरल गैस। You can produce so many products from natural gas thanks to the advances that happen. Methane, you can have methane reformer and produce ammonia, urea. You can produce acetic acid, methanol, DMT. And these days people are, you know, our Niti Aayog has come out with a base paper. और वो base paper क्या है? वो बोलते हैं methanol economy. They also call it C1 economy. जितने भी young researchers हैं, वो ये पढ़े methanol economy का क्या concept है। They say we will not use, of course, Government of India today is talking about 20% addition of ethanol and petrol, but they are saying instead of ethanol, go to C1, go to methanol, and go to dimethyl ether. And country like China, which does not produce methanol, buys methanol from either Australia or from West Indies or from other parts of the world like Nigeria or Middle East, and they produce methanol to dimethyl ether. India will also have to do it. In India, we have methanol manufacturing plants, but they are all shut down because our methanol is not viable commercially. The future is going to be green hydrogen, and the future is going to be biomethanol. I was in the committee for project on methanol, and this was my suggestion, advice. And again, I emphasize it here in Jamia Hamdard University. All research scholars must pay attention to this. When you produce methanol from biomass, remember, forget about petroleum. We have to go everything from biomass. When you produce methanol from biomass, we have to club methanol along with hydrogen. Because remember, CO plus hydrogen will give methanol directly. But when you burn a biomass, you don't produce all CO. You also produce CO2. And when you have CO2, you can't react CO2 straight away to get methanol. You have to have hydrogen. So you have to have a biorefinery where you produce biomethanol plus also hydrogen. This is a wonderful advancement, and it is not theory. It is not something idea. This is something which is going to happen very, very soon. And I have myself got the experience of it. I'll tell you this. These are some of the future products. Okay. We produce CO2. We capture CO2. If you go on the net and you write my name and write purple surfactants, you will find my name there. So I have seen black carbon to purple carbon. You know, मंत्री जी, आपको आश्चर्य होगा, हमको सबको पढ़ाया जाता है, हम ऑक्सीजन लेते हैं, कार्बन डाइऑक्साइड छोड़ते हैं, बस इतना है। हमारे शास्त्रों में इसका वर्णन बड़े बढ़िया तरीके से, और मैं क्यों बता रहा हूं, क्योंकि आज वो ही हो रहा है। हम ऑक्सीजन लेते हैं, लेकिन शास्त्रों में कहा गया है कि जब शरीर में ऑक्सीजन जाती है, ये 5 प्रकार की होती है: व्यान, समान, अपान, उड़ान और प्राण। हर एक का अपना रूप है, हर एक का अपना रंग है, हर एक की अपनी प्रकृति है, हर एक का अपना धर्म है, हर एक का अपना कर्तव्य है, हर एक का अपना कार्य है, हर एक का अपना फल है। और हम इतने सारे लोग, कोई ना कोई रोग होता रहता है, वी डोंट लुक इनटू इनसाइड। हमारे पूर्वज कहते थे अंदर देखो, लंबी गहरी सांस लो। अरे भाई, लंबी गहरी सांस ही तो नहीं, लंबी गहरी सांस लो, केंद्रित करो जहां पे रोग है, वायु से सारे रोग है। अच्छा, ये बात मैं इसलिए बता रहा हूं कि आज यूएस जियोलॉजिकल सोसाइटी एंड ऑल द बिग मल्टीनेशनल्स आर टॉकिंग ओनली वन थिंग, कार्बन रेनबो। जैसे कार्बन, हमको बताया कार्बन का कलर ब्लैक होता है, ग्रेफाइट ब्लैक होता है, कोल ब्लैक होता है, बट नो, कार्बन पर्पल है, कार्बन ब्लू है, कार्बन टील है, कार्बन ग्रीन है, डिफरेंट डिफरेंट कलर्स है, कार्बन पिंक है। तो ये रॉ मटेरियल्स जो हैं, दीज आर द वंस व्हिच विल बी ऑफ फ्यूचर, ऑल विल कम फ्रॉम बायोमास। दिस इज समथिंग व्हिच इज हैपनिंग, फ्यूल फ्रॉम CO2। देयर इज अ कंपनी कॉल्ड LanzaTech, एंड आई हैव वर्कड विद द टेक्नोलॉजी ऑफ LanzaTech in which CO2 is captured from। अब जैसे हमारे दिल्ली में AQI कम हो रहा है, अगर मान लीजिए हम ये सारा CO2 एब्जॉर्ब कर लें तो एकदम AQI ठीक हो जाए। पराली बर्निंग, मंत्री जी, पराली बर्निंग एक बहुत अच्छा प्रोसेस है। देखिए, मैं गांव से आता हूं और मैंने खेती की है, गायें पाली है, भैंस पाली है, हल चलाए हैं, ऊंट का भी हल चलाया है, बैल का भी हल चलाया है, उपले भी थेपे हैं, गोबर उठाया है। तो मुझे पूरा साइंस और ये अप्लाइड साइंस और ये पूरा बचपन से ही आ गया। तो मैं आपको अभी 10 मिनट दूंगा, 5 मिनट, चलो ओके ओके ओके। तो ये देखिए, अभी ये बड़ी अच्छी बात थी, मैं बता रहा था आपको। तो अभी क्या है कि देखिए, पराली जलाते हैं, तो हम लोग पराली जलाते थे, यहाँ साइंटिस्ट भी बैठे हैं, सब लोग ध्यान दें। हर न्यूज़पेपर में आजकल ये होता है, कितने पंजाब में पराली जलाई, कितनी। इनको ये नहीं पता जब पराली जलती है तो बारिश आती है, ये नहीं पता इनको। अच्छा, जब हम पराली जलाते थे तो पराली इज बेसिकली बर्न फॉर कार्बोनाइजेशन ऑफ सॉइल। धीरे धीरे जलाते थे, पानी छिड़क के जलाते थे। अभी क्या करते हैं, पेट्रोल छिड़क के जलाते हैं। दैट इज द ओनली थिंग व्हिच आई एम अगेंस्ट इट। सेकंड थिंग इज, ऑल दैट इज बीइंग बर्न्ड इज अ बायोमास। यदि हम वो 4 इंच का पोर्शन निकाल लें, थैंक यू, तो अगर वो 4 इंच का पोर्शन निकाल लें और उसको CO और CO2 में कन्वर्ट करके मिथेनॉल बना लें, दैट इज द बेस्ट वे। अब बैक्टीरिया आ गए हैं ऐसे, दिस इज द एडवांसमेंट ऑफ बायोलॉजिकल साइंसेस। सरवर आलम जी, बैक्टीरिया ऐसे हैं कि अगर आपका हाइड्रोजन लो है तो अपने आप हाइड्रोजन प्रोवाइड कर देंगे। ये देखिए, इट्स लो हाइड्रोजन, हाई हाइड्रोजन, हायर कार्बन। the bacteria will maneuver and it is a LanzaTech technology in place। चाइना में 2 प्लांट आ गए हैं, IOC के साथ उनका सिग्नेचर हो रहा है, LanzaTech का IOC कमीशन हो रहा है। IOC में प्लांट कमीशन हो रहा है जिसमें रिफाइनरीज का CO2 विल बी कन्वर्टेड इनटू इथेनॉल, बायोइथेनॉल. This is something which is happening, which I am also responsible for it. You have LanzaTech technology to convert CO2 in the atmosphere into ethanol to various products, including polyester. ये CEO यूनिलीवर ने आज से 6 साल पहले डिसाइड किया कि हम सारे पेट्रोलियम बेस्ड प्रोडक्ट को रिप्लेस कर देंगे बाय बायो. And this is what it is. They are doing it with the surfactant manufactured in India, and I am part of this technology. Lululemon is the biggest polyester manufacturer. Says that we will manufacture polyester from CO2 absorbed from atmosphere. This is the mass balance. You will have biorefineries where all the parali which is being burnt will be burnt in the biorefinery to produce methanol and ethanol. This is the perfect example of India Glycols, where they are actually converting bioethanol into various products. ये ट्रेंड है इंडस्ट्री के. ये देखिए COP27 में हमारे प्राइम मिनिस्टर ने एग्री किया, कमिट किया कि भारत में कार्बन न्यूट्रल हो जाएंगे बाय 2070. चाइनीज प्रीमियर ने कहा वी विल बी कार्बन न्यूट्रल बाय 2050. Some of the European countries have said we will reduce by 75% by 2030. But by and large, अगले 20 से 25 वर्ष में we have to be carbon neutral. These are some of the partnership trends, but this is what I was talking about, the carbon rainbow concept. And the young scientists must remember this, that it is the purple carbon which has gone to the atmosphere, we have to capture it. Okay? बस last में आता हूँ. This is the biomass. All products have to be converted, and this is the final thing. तो जो पूर्व में हमारे पूर्वज करते थे वो अब सब बोल रहे हैं वैसा ही करो. क्या करो? बायोमास से सब कुछ बनाओ. हमारे पूर्वज सब बायोमास से करते थे. This is the technology from biomass to ethanol, bioethanol. And ये ऐसी टेक्नोलॉजी है जिसमें एंजाइम भी आपको बाहर से नहीं लाना पड़ता. It is a self-generating enzyme. And you see this is the future. Non-virgin petroleum, petrochemicals for future. Okay, blue carbon, purple carbon, brown carbon, and gray carbon. And this is 2025 से 2105 का ये फेज है. जो ये वाला फेज है, this is the phase where life cycle is nothing but life to death. Okay, cradle to grave. I always say cradle to अंत्येष्टि, because पंच महाभूत का कॉन्सेप्ट ही ये है कि 5 तत्व से बना शरीर 5 तत्व में ही मिल जाएगा. So this is what the concept which is there. Path forward is innovation, and path forward is कि जब बड़े-बड़े लोग बैठे हो तो अधिक समय नहीं लेना चाहिए. यदि वो कह रहे हो कि समाप्त जल्दी करो तो जल्दी कर देना चाहिए. मैंने थोड़ा अधिक समय ले लिया, आपसे क्षमा चाहता हूँ, लेकिन आपका आशीर्वाद मिला क्योंकि मैं वहां से लेके वहां तक देख रहा था कि आप सबने मुझे आशीर्वाद दिया. बहुत बहुत धन्यवाद. भगवान भला करे.
May I request everybody to give a standing ovation to Dr. Kandal.
Thank you so much, sir. So now I would like to request our Honorable Vice Chancellor Saab to present Now I request Professor G.S. Kapoor to present a memento to Professor M.S. Alam, organizing chair. I request Professor G.S. Kapoor to present a memento to Dr. Hina Hamid, organizing chair. So now I request Professor G.S. Kapoor sir to say a few words about the conference.
Citation.
Honorable Mr. Sir, Honorable Vice Chancellor Sir, and dignitaries of the dais, it's my pleasant duty to say a few words about my very dear colleague, Dr. Christopher, who will be very soon superannuating from the services of Indian Oil Corporation. And we would like to felicitate him, sir. I will just request for 2 more minutes of your presence. Dr. Christopher was born at Chennai on 30th October 1963. He obtained his bachelor as well as master's degree in chemistry from Loyola College, Chennai, and got his PhD from Indian Institute of Technology, Chennai in 1990 in the area of catalysis. Dr. Christopher joined Indian Oil Corporation Research and Development Center in 1991, a research officer in Electrical Division. At present, he is Chief General Manager heading the Electrical and Project Departments. His areas of interest are catalysis, solid-state chemistry, surface science, tribology. He has more than 30 years of experience and expertise in the characterization of petroleum and related products and alternative fuels using various analytical techniques. He has 40 patents to his credit and more than 75 national international publications to his credit. Other notable contributions made by Dr. Christopher are compilation of 225 analytical test methods for analysis of petroleum products in the form of golden jubilee test method and 100 test methods for the analysis of raw materials and finished products using various techniques for catalyst manufacturing unit. And friends, this is the India's only catalyst manufacturing, refining catalyst manufacturing unit in the country at Panipat Refinery. Dr. Christopher is a life member of Indian Society of Analytical Scientists Delhi chapter since 2000 and have been passionately involved in all the activities of the chapter. He held various posts in the executive committee and contributed immensely to various activities of Delhi chapter. Presently, he is the chairman of ISA's Delhi chapter. He is also a life member of Catalysis Society of India and Tribology Society of India. Considering Dr. Christopher's significant contribution to the growth and activities of ISA's Delhi chapter for more than 20 years, the executive committee of ISA's Delhi chapter takes immense pleasure in felicitating Dr. Christopher on the eve of his superannuation from the services of Indian Oil Corporation by presenting him this citation as a token of our gratitude and wish him all the very best for all his future endeavors. And मैं मंत्री जी से रिक्वेस्ट करूंगा कि अगर हमारे बिहाफ पे डॉक्टर क्रिस्टोफर को ये साइटेशन
Now we invite Dr. Hina Hamid, the organizing chair, to express her gratitude with vote of thanks. I may now request
respected dignitaries on the dais and off the dais, dear colleagues, students, and delegates who have made this event possible. A very good morning to you all. On behalf of Jamia Hamdard and Department of Chemistry, I wish to express my heartfelt gratitude to our Chief Guest, Mr. Imran Hussain Sahab, Honorable Minister, Government of Delhi, for sparing his valuable time to be with us today. We are equally thankful to Professor Faizan Sahab and institution in its own right for being with us this morning to encourage and inspire the delegates who have joined us today. We are grateful to Professor Rakesh Kumar Kandalji, a researcher par excellence and known for the conversion of ideas from lab scale to commercial scale, for setting the right tone for the scientific deliberations that will follow in technical sessions. We feel utterly blessed, sir. It is really difficult to put in words the respect and appreciation for our Honorable Vice Chancellor, who has always been supportive of our initiatives and encouraged us to strive for excellence. What an incredible leader you are, sir. We are highly grateful for your leadership and for always being there for us, sir. I would like to express my sincere appreciation and thanks to Indian Society of Analytical Scientists, Delhi chapter, for joining hands with Department of Chemistry, Jamia Hamdard, in organizing this event. A word of appreciation for our sponsors who have financially supported this event. Your sentiment of promoting and encouraging science dialogue is indeed praiseworthy. I would like to acknowledge the efforts of Imam Rabia Mosque, Mr. Abdul Malik Faruqi, Sahab, the President Music Club, Dr. Nishat and her team, Cultural Coordinator of the University, Ms. Seema Rani, in charge Scholar House, Mr. Tanveerul Haq and his team, Secretarial staff of VC, Registrar and Finance Office for their support, for always being there for us, and also the audiovisual team of the university. I would also like to put on record my appreciation and gratitude for all the volunteers and other members of organizing team, both from ISAF DC as well as Jamia Hamdard, for acting cohesively behind the scenes to shape this event. We are gratified by the immense response received for this event from the delegates who have come from different institutions to join this scientific mela. I sincerely hope that it is highly productive and an impactful experience for all the participants. And I would like to inform you that there are 6 Best Posted Awards for you, waiting for you. Thank you all.
Thank you, ma'am. So we are inching towards the closure of the inaugural ceremony. So before that, I request you all the delegates to stand up for national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाए तब जय गाथा जय जय मंगल जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे भारत माता की जय.
Now we will proceed for the high tea and we will assemble back at 12:15.
बुकिंग कार्ड देती हूँ भाई. ऑनलाइन लाइव चल रहा है यूट्यूब में, ऑन कर दो ऐप It is featuring 2 invited talks from distinguished speakers. Please be inspired by their expertise. Session 1 is going to be chaired by Professor G.S. Kapoor, Executive Chair, ISAS DC. Dr. Kapoor is a consultant in energy transition and petrochemicals, an adjunct professor at Jamia Hamdard, Department of Chemistry, and a visiting professor at the University of Ladakh. He is a renowned and he is known for his significant research career, having recently retired from Indian Oil Corporation Limited as Executive Director. Dr. Kapoor holds a PhD and MTech from IIT Delhi and has conducted postdoctoral research internationally. He boasts an impressive record of 373 patents, about 125 research publications, and has mentored more than 30 MTech and 5 PhD scholars. His remarkable contributions have earned him numerous awards, including the FICCI Chemicals and Petrochemicals Award, FIPI Innovator of the Year Award, and recognition for innovation in polymer science and technology. Now I request Professor Kapoor sir for chairing the technical session 1 today. Now the floor is yours.
In this session, we have so our first speaker is Dr. D. Sarma. He currently serves as a professor of history and food science in the University of Brazil, with extensive Dr. Sarma has superintended a long time from he also had the Department of Economic Institute. 45 years of research experience often looked at field. So without wasting much time, I invite Dr. Sarma to deliver his talk. The topic is qualification of seafood, microbiology, and the G20 system development goals for future research.
लाइट बंद नहीं आ रहा
25 minutes.
नहीं ये वाले लाइट
पॉइंटर फॉरवर्ड एंड बैक
ये है ये फॉरवर्ड ये बैक settle down quickly. So we are already very late.
माइक चाहिए
So light will not be lights.
Good afternoon. The topic is not a new, but the application are surprisingly immense. You might have heard algae. Algae is nothing. It is just a green material, which is you can find suspending on the wastewater, ponds, in the rivers, and all. Now you have heard now G20 summit was there last month, and this is one of the sustainable development goals, which is all the governments world over they're going to take up how to develop this algae so that it can help the society, it can provide a lot of employment and all opportunities. लाइट से नजर नहीं आ रहा, मेरे को नहीं नजर आ रहा है, फिर क्या पढ़ूंगा मैं? You know why this was taken as a sustainable development goals? You know, climate change and the pollution lead to depleted land and marine diversity. It really a challenge to the food security. You know, the food production is falling, not because of the, you can say, environment, so many factors are there also. Now, you know, the carbon dioxide, what is responsible for all the disaster? It is the carbon dioxide level, which is increasing. 2022 level, it is 454 ppm, which was about 200, about 100 years back. You can see in 100 how much it increased. And it will be 600 ppm by the end of the century present, I think there will not be anything on the board. Even we will not be there if it becomes 600. All ocean will melt, water will come out into our houses also. All the people living on the coastal area, they will all vanish that if it becomes 600 ppm. You know, the ocean, it's overfishing. You are available. We all depend on the fish as a food for our, you can say, survival. But so much overfishing. And there is not a prediction, it's a scientific evidence there will not be any fish after 2035. So you have to find out an alternative. Now, again, the temperature is rising because you can say the carbon dioxide level increases. So it's going to increase the sea level by 3.8 meters. I already told. This will be a disaster. If it increases by 1.9 degree, continue to increase by 1.9 degree. Now, again, you know, the deforestation, energy consumptions, petroleum products, all we are consuming and they are emitting carbon dioxide, so level is increasing. What all the country, G20 country, they all assembled there, they decided why not to get together and found out some solutions. So they gave solution also. One of the solution which carbon dioxide can be mitigated is an algae. Algae is, you know, it can be marine algae, it can be land algae also. So I'm going to describe, this is one of the best source for the sequestration of carbon dioxide, and it's going to be proved as a medical and a superfood for the 21st century. This is not a joke, this is going to be the reality. Now, actually, what is algae? Algal structure. You know, we all actually are a product of the microorganism. All over our there are microorganisms. Even coronavirus was a microorganism. So it can be two kinds. One, it depends upon the size, the shape of the organism. When the size is about 1 centimeter to 50 meters, very large, you can say there are forests of algae forest underwater in the sea also. So they are called microalgae or they are called seaweeds. And the second, we have the smallest particle like coronavirus, and the size is 1 to 50 micrometer, which is called a microalgae, which you find on the ponds, on the wall, on the rocks also. Now, these are unicellular and they belong to the cyanobacteria class. At the same time, the microalgae belong to the multicellular area and chlorophyll types. Now, you might have heard chlorella, spirulina tablets are available in the market. You can eat also. There are a lot of, you can say, health benefit. PUFA is available. Even cardiovascular treatments are available. So they all depends on all this also. Now, how algae grow? That is only algae for grow. It needs a microorganism, as I told you. Chlorella, synandromus, and so many there are microorganisms. You need a carbon dioxide. Carbon dioxide is plenty available. And water, of course, and the nutrients like fertilizer, which we provide to the crops for the growth also, and sunlight. It is basically a photosynthetic process, and you get a biomass. Okay. So people call it bio, but the one thing is very important. Carbon dioxide is absorbed, but it releases a lot of oxygen. 50% of the total oxygen which we inhale, it comes from the algae production, both marine and as well land algae. Now, as I told you, it is a photosynthetic process, so you need a carbon dioxide. So carbon dioxide is absorbed and carbon dioxide is mitigated. These are the plants, but rootless. Algae is like a plant. The way your plants grow, terrestrial plants, they grow, the algae also grow in a similar way, carbon dioxide and all the animals. But only it is a rootless. How it stands, it is like a, you can say, it just float on the water, on the sea, on the rocks also, that is. As I told you, people say, has not been an algae, we would not have survived. Now people are trying to find algae on the moon also, from where people will get a food. Algae is a food also, so scientists, astronauts cannot take a food, you can see to the moon also. It is very difficult to preserve. So they are looking for the algae to grow there, only need water. So when the water is there, so you can grow algae there. So that will be a wonderful food for the astronauts. Now, what is the phycology? Anatomy, you can say, as biology people say also. There are so many types. There are 3 different colors of the algae. You see the green normally, but there is a brown also. There is a red also. They all depend upon the sizes also. And so many types are there. You know, which is famous country which grow the maximum, you can say China and the Japan, they eat algae in the form of wakame kelp. Have you heard the kelp also? Irish moss, which you grow in the houses also. These are types of the algae, that is the macro algae, which you can grow in your house at the same time on the land, water and sea also. Now, 4 types are mostly important because they are easy to grow, easy to cultivate, easy to harvest. They are chlorella, spirulina, dunaliella, synandmus. Of course, there are about 30,000 species which are available, and hardly you can say about 200 and 300 have been explored for the potential for the society.
I would like to have the attention of the House. Kindly, this is a very important keynote this invited talk lecture. I would like to have the attention of every delegate to be participative rather than be involved in their own personal things. Thank you.
As Professor Alam has said rightly, I'll come to last slide. You can innovate in your laboratory, all these things also. It's not only that you need some space, or in the laboratory you can do all the exercise. I'll continue. Now, actually, there are 3 types. As I told you, that is the anatomy, or you can say the physiology of the algae. One type is called Phyceae, which is a brown algae, which has a bigger side, 50 centimeters. If you go to the rivers, to the rocks in the sea also, you see the forest under the water. And the forest underwater is nothing but is a macroalgae. It grows on its own. You need not to supply anything. All the organisms are present in the water, seawater. Second type is a chlorophyceae. Have you heard the chlorophyll? Green material which is present in the plant. Because of chlorophyll, all the photosynthetic process occurs. So they have a different sign, only 1 centimeter to 1 meter. And the last one is called a rhodophyceae, which is a red algae, Irish moss. Kelp, you might have heard also. Normally, it can be eaten very easily also. And all type of snacks in Japan and in China, they are prepared for this. Now, there are 900 species, 4,000 red species, 15,000 brown. These are the limited. There may be so many also, still to be discovered. Now, how this photosynthetic process, he says carbon dioxide is all around. Some agents are available. Plants is one of that is the best agent which can absorb carbon dioxide. That is only comes to 50%. Rest of the 50% is absorbed by these algae only in the water and on the marine. Now, marine algae and land algae, they absorb 50%, terrestrial crop 40%. And there is also absorption by the land rocks. All the carbon dioxide under pressure, it goes into the sea also and turns into the rocks also, which is called a calcium carbonate rocks also. It means there is a preservation of the carbon dioxide in the sea also. Now, this is the equation which is generally taught in our 10 to 11 classes, how carbon dioxide convert into useful product by the process of photosynthetic and releases carbon dioxide. So it is just algae is a life-sustaining respiration by the microorganisms. Now, as I told you, there are extraordinary super properties of this material. What we do, we grow algae, collect algae, dry the algae in the sunshine also. We get green materials, red materials, and brown materials. What are the applications? There's a food and nutrition. It is a source of oil and fats, beta-carotene, all the vitamins, they are present also. This can be as a food security for the future. Agriculture, it can be used, the whatever rest over after the extraction of the vitamins and the oil and fats, it can be used as a fertilizer. It's all a natural fertilizer, rich of nitrogen and phosphorus, better than urea and superphosphates. And polysaccharide, all your curd, all material gels and ice cream. We are adding an artificial coagulants, anticoagulants, and gel forming agents. But in all you can say the 50% of the Asia, they are using algae as a coagulant, as a gel forming agents. So they are all nothing polysaccharide, carrageenan, and alginates and agar, you might have heard. And at the same time, they are super absorbent. They say 1 gram of this algae can absorb 99% of the water. You can say how much it can retain in water. And it can be used as a conservation of water also. Bioplastic, what is the plastic? Polyethylene, polypropylene, really it's a degradation, spoiling of our atmosphere environment. But it can produce as a bioplastic, and it is a replacement of single-use plastic, your poly bags and other things also. Then pharmaceuticals, people in the past, I'm talking about maybe 500 years back, they never use any your antibiotic also. They were dependent upon the plants-based herbs and animal. And algae is nothing. It is also a lot of containing herbs also. Contains all, there's even molecule equivalent to paracetamol, molecule equivalent to all antibiotics. So it's a very good source of pharmaceuticals. And a lot of industry is thriving on this also. So it means this can provide health security also. Now biofuels, bioethanol, hydrogens, biohydrogen, biomethanol also, biodiesel also, because it contains a lot of oil and fats like your soya oil, similar to soya oil, sunflower oil. So it can be converted into biodiesel also. And the residue by the degasification can be hydrogen and further carbon dioxide and methanol and ethanol. So it's a medical food and called a superfood of the 21st century. Why that is G20 are so much interest to take up these projects also. And there is socio-economic security to the coastal population. Because coastal population, they can thrive. They depend upon a lot of employment can be generated. They can sell their products in the market and have the livelihood. Now, these are the products. As I told you, in this multi-products. There are about 15,000, you can say, chemicals that are present in this. That is maybe the least also. You can have a vitamins, all types of vitamins, which you take as artificially, or some of the vitamins are synthesized in our body also, like B12. You can say D vitamin also. So it is all vitamins. Dietary supplements, carotenoid. आपने वो जो गाजर खाते हैं, गाजर में कैरोटीन होता है. It is all present here also. All at the same time, PUFA, PUFA, polyunsaturated fatty acid, omega fatty acid, DHA, EPA. It's a rich source of this, that is algae. Both marine and as well as, you can say, the land-based algae also, microalgae also. Antioxidant, and it can also, because since it contains oil and fats, polysaccharide also, so high-performance lubricants can also be prepared from these, you can from the biomass also. Now, as I was discussing the gel forming agents, also gel forming agent, it has a structure like this. They are nothing but galactose, you can say fructose, galactose. So polymerization, they convert into alginates. Alginates are the salt of alginic acid, so very important also. Most I told you, most of the industry now they are turning towards the natural products. So they are using in the ice cream, in the even you can preserve, add a parts per million of these alginates into the milk. You can preserve the milk for 100 days also without, you can say, any, you can say, artificial preservatives. So carrageenan also is the same thing also, that is okay. Now, what is the composition of biomass? As I told you, there are a lot of material, but they can be divided into 4 or 5 classes. First is the oil and fats. You see, nothing same fat, which is present into your oil, soya oil, sunflower oil, jatropha, and all, you can say, the plant-based oils also. They have exactly the similar chemistry. Only distinction is that our soya oil does not contain, you can say, high type PUFA. It contains high type of PUFAs also. Proteins, it is the same protein, all the essential proteins which our body needs, body required for our building, for muscle and others also. Our survival, they are present into the algae also. They are actually, body protein is a polypeptide, that is a chemistry. All the carbohydrates, polysaccharide I discussed, that is a very high amount also. Now, our body needs some minerals, calcium, potassium, sodium, zinc, and also, or you can say, so many catalytic processes happening in our food has to be broken into so many molecules for the carbon dioxide and providing energy. So all these metals, minerals, they are present there. And all the vitamins which our body needs also, they are also present into that also. Now, as I told you, there are thousands of species are present, but these are the species which are being commercialized for the production of these products, which I'm talking about, vitamins, chlorella, spirulina, and endemis, you might have heard also. I think the botany and geology people might be knowing better also. Now, seaweeds, as I told you, seaweed size, as I told you, the size of this microalgae is less than coronavirus. Coronavirus is about 400 micrometer. It has only 1 to 10 micrometer. But seaweeds, they are like a plant, like a tree, but no roots and etc. If you go to the, you can say, the rocky sea type also, you'll find all these also. That Now, why is it so important? Why not to grow plants and other also? Because plants, of course, carbon dioxide sequestration also. But at the same time, the yield, the photo efficiency conversion is very high. And the crops you get in 15 to 20 days, algae crops, compared to the crops of, you can say, your plant crops, which you get only in the 3 months, or you can say 2.5 months also. And the yield, that the production of oil, per liter, per you can say per 100 grams or per acre of the land, it is about 4 to 10 times compared to your plant, or you can say plant-based crops also. Simple example, corn, you might have the corn also, soya, 18 and 48, that is a gallons per acre per year, which compared to, you can just say 8,000 algae, that is. This you can just say 8,000 also. And the seaweed is also, how much you can say, much you get an oil. That too, how much per year also, compared to all these things. So it's very, so crops are there, but it has a similar nature to this, you can say algae. That is. So, the one thing which is very important with algae is you can synthesize any molecule in the laboratories. It's not only you can put oil and fat. It depends upon what I'm going to describe also. It's like a, so you can say, a natural catalyst. Now, scientists are now trying to prepare, to synthesize in the laboratory all the antibiotic which we are taking also. Now, there are company coming up also. It's $1 million job now, $1 million industry, you can say nowadays. Now, of course, algae is growing on the ponds, wastewater also, but there is a called algae farming. You can do the farming also. You can say grow the algae in the tanks, on the land also, on your rooftops also, and you can create a small ponds also. So these are the different type of techniques also. See, the raceway ponds like it's like a field also. You prepare so many feed, and you can say take water from the sea also. You can take water from the industry also, and you can grow also. Now, the best way is called the submerged type, photobioreactor. These are the photobioreactors where you can see in the tubes, in the synthetic tubes, like your pipes also you can take, fill the pipes with the water, add some nutrients also, and you can even grow the algae also. So all the pharmaceutical products, they are being grown in this type of photobioreactors also. Because it's the higher photosynthetic efficiency. As I told you, the plant's photo efficiency is 2 to 3% of absorption of carbon dioxide. But algae, it has a 10 to 15%. How much carbon dioxide it can take, convert into products also. So as I was talking about, the seaweeds are grown into the sea also, but you can take the sea water into your field also. Now, these are types of how you can say take a ropes. They are taking ropes also, tying the seeds onto the ropes, and they are putting into the sea also. So after 20 days, the maximum 40 days, you can get a seaweed up to the height of 50 meters also. That is different types also. So this is the way they are, how they are growing also. Look at it. So it is single row floating, fixed bottom, long line methods, coil method, and spider web. It's like only you prepare a jar type also, and you can grow. That is an algae. So these are all the, you can say, an artificial methods. Now I'll come to also, I was talking about, see, this is a very vast topic. I will be discussing only the PUFA and at the same time other food and proteins material also. Now, what do you need? When you grow crops, you need a water, carbon dioxide, of course, available. You need a nutrients also. And it is a role of only these chemicals nutrients, nitrogen, phosphorus, and the minerals, which actually boost the production of the algae. And at the same time, you can have a tailor-made materials, customized materials also. The concept is called molecular engineering. It means you can engineering a molecule of your type. If you want oil and fats, this oil and fats, for biodiesel, you can prepare this type molecule. If you want proteins and PUFA, you can prepare a PUFA. If you want a specialty product, vitamins and fatty acid, so it means you can do chemistry in your laboratory, and then you can, after the laboratory, you can go to the pilot plant and you can the industrial levels also. This concept is called molecular engineering. And fertilizer is nothing. You can use urea, superphosphate as a material because in general water, the quantity of this nitrogen and phosphorus is very, it's not sufficient. We have to add some materials. So I'll come to oil and fats. Now, these all types of fatty acid, they are all present into the algae. Look at all these fatty acids, they are present in all soya oils, sunflower oil, jabroni oil, all these types. They are similar. You can see 16, 18, all these fatty acids. And the interesting part is these PUFAs, except C18-3, they are not present in the vegetable oils. Vegetable oil contains only soya oil, which contains 7 to 8%. But all these are essential PUFA, which are required for our, you can say, health benefits, heart benefits also. They are all present also. So algae is in a position to synthesize, but you have to modulate the conditions. You have to change the condition. You have to change the media also. Another thing also, you heard why mother milk is so healthy. There is a question. Why not? Cow milk is similar to mother milk also. There is stereochemistry involved. That is the arrangement of the molecule, the fatty acid around your glyceride. They say that when you have a saturated fatty acid, unsaturated fatty acid at the center of the molecule, the assimilation, that is the baby assimilate milk in a better way compared to the other milk. So that is again this type of algae, this type of chemistry present in the algae. Now, these are the species which you can have a laboratory. Almost I worked in Indian Oil Corporation and abroad also 4 or 5 laboratories. We took all the species also and try to synthesize the molecules into the laboratories. Now, this is the biomass. This is the biomass we collected. This is the Dunella serina, which produce vitamins at the vapor kinetics. So the cultivation media was superphosphates, urea, and sodium nitrite. These are the superphosphate, the fertilizer. And our solvent extraction process was ultrasonic with chloroform and methanol. So this is the way how you can do the extraction. You have so many ultrasonic, mill beating methods, simple, you can say your oxide extraction method. So many methods, there are similar methods which is used in even the press mill methods are available, which is used for the extraction of oil from the algae. So after the extraction, not only you have to do the innovations. What is the present in the extraction portion? So what do you need? You need analytical technique. So we applied almost all the analytical technique, but I will discuss only the few techniques only. These are the techniques: NMR, IR, MS, and GCMS techniques. Now, I know for a beginner, NMR is a very powerful technique, which can differentiate among the different type of hydrogen, different functional group, and you can correlate the functional group with different type of molecules also. See, you can have you can say this type of ester. This is an ester type between glycerides. You have PUFAs also at the same time, long alkyl chain fatty acid. So you can distinguish. You can distinguish all these. You can say. So it means you can 20, 30 parameters by single parameter. Ordinary value you can estimate. You can evaluate what the oil and fat content, what is the PUFA content, what is the unsaturation content at the same time, what is the glycophosphate content. All can be you can say determined with the help of NMR spectroscopy. Now, this is another technique which as I told you, I was talking about. You can say the distribution of different fatty acids. What are the types of the fats, fatty molecule, glyceride? It can be even with the help of mass spectrometric technique, which is an ionization technique. Depends on the molecular weight also. So you can differentiate, distinguish, and estimate. And these are different. You can say all different type of fatty acids. You can fatty C14. How they are attached to the different sites, it can be determined with the help of a mass spectrometer. This simple gas chromatography and mass spectrometry, where you can have all fatty acid profiles. All fatty acid profile you can say. This is PUFA. C26 is a DHA. This is 23. You can see two different type of you can say these are algae, synandrous, at the same time The second one is chlorella. How they differ? This contains the highest amount of PUFA. This contains the minimum amount of this PUFA molecule. So all carbon distribution can be determined with the help of this technique. Now, so this is the, you can say, as I told you, different type of algae species are available. Different type of materials are available. Means your this nutrient material, you can change over the concentration of the fertilizer, nitrogen, and phosphorus. So you can have a different type of the composition. So different, you can say chlorella, different component TG, that is a glyceride composition. So it means it all depends on this material, where you can have the maximum number. They say you can have a PUFA type of a TGA when you high nitrogen content, high phosphorus content. But if you want to produce a saturated and unsaturated fatty acid mono acid, you have to deprive the algae nitrogen phosphorus. It means you have to grow under stress, or you allow the algae to starve, so that you can have a molecule of your type. Mean that so that is the biodiesel material. No, I think I'll go to the end after Dr. Kapoor is emphasizing. This is my last slide, of course, right? To see, I have tried. This is all work has been done in a you can say laboratories also, which is the cow milk from the market to the Brazil market. Mother's milk, of course, we try to get. There is one laboratory who was doing research on mother, so we took some samples and tried to analyze that we extracted oil and fats. Now the main point is, all the company in the world over, all the commercial companies, they are emphasizing that why not to take a PUFA. PUFA means DHA and EPA molecule, which is good for the brain, you can say the development of a child. If you look at also, is it containing? This is PUFA. Trace only mothers and cow milk. But fish contains very high amount of also. So it means it is just a selling, you can say that the strategy also. No PUFA is required for the child. It is the mother milk is sufficient, which give you all the, you can say, the essential fatty acid for the growth also. Now seaweed, look at even seaweed also, which is our trying about algae also, it does not contain PUFA also. But PUFA maybe you can say better for the development of our, you can say, the infant when they attain the high, you can say the 4 to 5 year old infants. So you can say how much they differ. So algae and these almost there is no difference, when only except the PUFA also. So the mother's milk, cow milk, and milk, no milk for algae is produced nowadays also. So they have the similar characteristics, similar containing essential fatty acid and amines also. Now this slide will stimulate interest in you. It will make you passionate. How much India is doing research? 7% on this. China, 29% research is doing. Others 31, US 40%. It means a lot of scope. You can involve. Do your research, produce all these essential chemicals, and you can do a lot of it. Not only you can serve the society. That is why G20 is after. Why not did they say they produce algae, marine algae, and other stuff? So, and in marine algae also, India is only 3%. Look at China, 40%. Because they are producing so many products, eatable, you can say edible products also. So this is my conclusion. Look at what is the potential of an algae. Every material you can have it. You can say that is the biodiesel. You can produce food and proteins, particularly PUFAs also, biodiesel, MUFAs. So many you can say. You can monitor, process, and produce a chemical of your choice also. So these are my collaborators. I've been in the past. I worked by serving abroad in this laboratory, and part of the work I have that is presented, that is all it is a published. It's original work. Nothing is taken from, you can say, the stolen from the, even you can say stolen from the literature also. Now my future collaborators are Federal University of Brazil, which I'm not going to join next month as a professor of chemistry and food sciences. They are working on algae, oil and fats, and other even biodiesel also. And I invited Professor Alm also, Sarval Alm, and he has also shown some interest to work with me. And so you are all also invited to work with us and let us explore the new possibilities in the field of algae. This is the last slide for you. That is, what is algae? You look at it. That is. So this is a message from the government of India. Message for all of us: save and conserve water and power. Jal hai to kal hai. So algae is one of those which is, you can have a lot of preservation of water. Even algae creates water also. That's a very, you can say, fundamental chemistry also. So thank you very much for your kind attention. If you have any question, I will like.
Thank you, Dr. Sabha. As we have late, so and have interacted in the last time. Thank you very much, Dr. Sabha.
एक सेकंड. So now I would like to request our chair to honor the speaker with a moment.
Thank you very much for this opportunity.
So the next talk is a recorded talk. That's Professor Shamil Ahmed. He'll be talking on carbon nanorods, structures, properties, and materials. Sir Ahmed is a distinguished professional versatile background, studying electronics, technology, mathematics, and natural colors, and IoT systems. His notable achievements include developing space-qualified microsensors, establishing application right for microelectronics, contributing to semiconductor realization. Jamia Hamdard, he initiated a program for manual connected to perform the electronics.
पेन ड्राइव बज रही है आपकी. पेन ड्राइव बज रही है. पेन ड्राइव झिल रही है.
Various challenges in technology. So, you know,
एक मिनट. पाँच मिनट के बाद.
हाँ जी, बैठ गया.
पूर्व ये वाला लेक्चर ये बाद में कर लेंगे. पहले चला लो वीडियो. उसके बाद
अभी तो कौन सा है?
सर का शमीम साहब.
हाँ, नहीं मेरा वाला. हाँ,
वीडियो आ रही है.
पहले उनके बारे में बता दिया, स्पीकर के बारे में.
हम बता रहे हैं.
अच्छा.
I'm going to talk about carbon nanorods. It may appear to be a very simple nanostructure, the family, but it has very unique properties which are distinct mark me. Well, when it comes to this today's point of discussion. These carbon nanoparticles are actually fluorescent detectors of our type, which may have advantage of low toxicity, good selectivity, high sensitivity, and stable stability. And because of these features, these nanoparticles or carbon nanorods are attracting more and more attention from researchers in the carbon nanorods. This is a shell core type of structure. There is a core which is shown here in blue color, and the shell is of red color. And there are a number of spokes like things coming out of that, which are actually the amine bonds available on the surface, and they are very useful for attaching number of chemical species and molecules to this simple carbon nanorods to make it more useful for number of unique detection techniques. Now, if we quickly try to see what are the different types which people have across or which people have synthesized, we find that there are 3-4 types simply which are practiced very well, and they are manageable because they have been analyzed and they are synthesized in a very successful manner. The first lot is that graphene based on compounds. But even on the case, when graphene is known, after that, anything to start using carbon related nanoparticles. Graphene is one of the simplest starting point, and from there go to the extent to realize that in form. So graphene carbon dioxide one, which had hexagonal lattice structure and confined to dimension of less than 10 nanometer, as shown on the left hand side. Right? Then amorphous carbon rocks instead of crystalline carbon, there are possibilities where the mass of amorphous carbon dioxide as shown on the left hand side. Then graphitic carbon rocks. Actually, this is a multi-layered carbon dot where each layer is of the tree. And the fourth one is graphitic carbon nanorods, where this is not purely graphitic, but it is C3N4, that is called graphitic carbon, which is again a very useful material. And a lot of activities are going on in this material. People are trying to use it for a number of applications which are not foreseen earlier. And try to examine the DEM and HRD in biology DEM program. You may notice that there is a lattice spacing of 0.21 nanometers, and that is compatible with 100 orientation. Now, you may ask, how to prepare, as I'm saying again and again, it's very simple, how to prepare or how to synthesize these carbon nanorods. I'm giving some example, starting with the bottom synthesis, where the number of carbon family materials indicated on the left-hand side, they are either subjected to hydrothermal and number of processes which are shown as 3 in middle, and then finally we have the carbon nanorods covered with the sheet. And this is the bottom synthesis. You can go into the details if you're interested to prepare and use it. On top-down synthesis, we start with, more basic materials like flat graphene sheet or buckled graphene sheets or carbon nanotube. Instead of that, you can use also, this C60 molecule and use it in art discharge, electrolytic methods, and several of them. You can get the same carbon family as shown on the right side. Now, if we look at the literature today, we can find that these carbon arts can not only be prepared by some chemicals as shown earlier, there are one of them, but interestingly, they can be prepared from number of herbs or spices which we use in our day-to-day cooking. This is what I wanted to highlight, that this has got some implication which is generally not seen by the scientists in that sense as it is for the common people. We can start from this drugs, basic, turmeric, cardamom, and this is still much bigger. What I want to say is that you use these precursors like basic leaves, turmeric, cardamom, and using this as a precursor, you can synthesize just by, and prepare carbon logs of less than 10 nanometer size with fluorescent properties which can be very sensitive and highly effective in number of applications. For example, these materials are antifungal and growth retardant, anti-cancer, and whatnot. These are only basic few things which have been mentioned, but can be reused. So the question is how deeply you look into it and try to understand that. Now let's go to the example of how to prepare carbon nanorods from turmeric. You can start from turmeric powder as shown on the left-hand corner, and then prepare the solid extract using ultrasound and ethanol. What you do is you put the powder in ethanol and try to polish it with certain power. You find that some turmeric kind of situation is there, means some suspension is there. Now you put that material into solvothermal reactor and heat it up to 185 degrees Celsius for 12 hours. You'll find carbon nanorods as shown on the right hand side with fluorescent property, means if you shine ultraviolet light on it, we get a typical characteristic color of fluorescence from this material. Now this material is ready for a number of applications. As you can see, you can use it in photodiagnose therapy and kill a number of pathogens and detect them. So you can see the property that this is starting with a very simple material, and in a history that you can use this material as a photodetector or detector at molecular level and show the presence of the bacteria or how it is killed there. Simultaneously, you can image them as shown on the left side. And the states are also there. So you can check whether whatever you intended has happened or not. Now, coming to another case where the arginine is used in a hydrothermal reactor at 180 degrees Celsius for 6 hours, you get a blue fluorescent suspension And this can be used for cadmium and mercury detection, which is very harmful, with impunity in number of cases. And we want to get rid of this is called heavy metal contamination. And in help of this material, you can detect. You can use different kinds of masking samples, like this vegetable food from this side, and then check the efficacy of this detector in a very predictive manner. A number of publications are there, those who are interested, they can look into the details, find out how beautifully this simple material can be used for very sensitive detection. Now, I have taken another example. Today, you hear a lot about green things, green foods, green materials, green processes. The reason behind this is that the process which you are using should not be harmful to the environment. The idea is extremely good, but to implement is rather complex in the sense that there are a number of factors which interfere particularly with the new implementation. I'll give you an example of ultrasonic and chemical oxidation based synthesis of carbon dioxide, starting from the green source like milk leaves. If you take milk leaves and chemically oxidize it at the upper portion of the wall, then you get carbon dots after neutralization, separation, and purification. On the other hand, if you take the green leaves and use a dry powder, dissolve it in distilled water, and centrifuge it, you will carbon dioxide. Now, why I have chosen this example? That is, you don't have to have very sophisticated synthetic protocols or materials. Rather, taking natural materials, natural quantities, and prepare carbon nanoblocs to use it for number. Nobody knows, maybe whatever we eat, whatever we use in our daily consumption, number of sources which you use are producing carbon dioxide during the processing of cooking. And we take advantage of those properties and features of carbon nanoblocs without knowing in our day-to-day consumption. So this is the subject of investigations, and you can find out that this art has involved very complicated molecules to be designed, structured, and synthesized very high cost. And they say that this is the treatment of our maybe we don't know, but we are consuming these materials in sufficient quantity already, and putting another load on that may not be very helpful at doing something which is not acceptable, which may not be acceptable once we know the behavior of that particular. So I just wanted to touch upon this concept that whatever we eat in the form of food, preparations prepared by numerous methods and food preparing sequences, we are taking large number of carbon dioxide, and we are coming to collection of all these, publications at the center, fluorescent material, carbon monoxide. And on the delivery are shown different applications. For example, starting with sensing. Sensing is selective sensing is used for typical molecules. So these are molecular recognition-based sensors which can be prepared by log the key mechanism of molecular sizes and the shapes. And as you know, you can go to the published lectures. Next comes phototherapy. Phototherapy means the therapeutic applications of some radiation and detection simultaneously. It is called therapy, where the effect of particular radiation characteristic wavelength and intensity, how it affects the tissue or how it affects where it is being put to use in providing treatment, can be simultaneously detected and used for therapeutic purpose. There comes another very simple example of anti-counterfeit. It is fingerprints. You can detect the fingerprints with the help of these carbon nanobars very precisely and at very low cost. There comes biology, which is another huge area where a number of applications are developed using these carbon nanobars. Photocatalysis is another area which is growing very fast, where the catalytic properties of the materials are used to initiate number of chemicals. For example, at room temperature, in the presence of sunlight, you can produce sufficient hydrogen fuel for future population. Then comes the light materials. You can prepare again light emitting diodes using carbon dots as one component, and then it is a combination. And like that. So, a number of laser applications have been explored and people are still trying to understand the material and these fluorescent materials for specific applications. Why am I emphasizing this material of carbon nanobars? That it is not very expensive as compared to semiconductor carbon nanobars. And it is not toxic, it is least toxic in that sense, and it has a number of additional advantages which are not possible in conventional semiconductor quantum box. This fingerprint detection examination is shown here on the left-hand side. You prepare the material and then you look at its fluorescent spectroscopy. After that, you prepare a display and display this liquid on the place where you suspect that some fingerprint is there. And once you shine it with UV light, you can detect the fingerprint in a very precise manner. Now, coming to the spices, that is, how many types of spices can be used for permanent loss. You can take some, you can take gradually, permanently, and lifelong. The different features are shown here in this table, and you can see that in a very simple manner you can use them as detecting medium for a number of biological applications which are not easily possible by other methods. Well, I have just touched upon the basic features of quantum structures based on carbon nanotubes. This shows that the refinement of electrons in a size smaller than 10 nanometer can be used in a number of applications in a very simple manner by carefully examining its characteristics and its properties in a very stabilized and non-toxic manner. The derivative product which you have made as the summary here, outcome of this is where this was shown that this is a simple process acting carried on using very simple chemical techniques, rising higher variations of discussion, even which can be tailored to number of not foresee otherwise. So with this, I would like you to understand that how this control is stabilized communication, how we did that function and talk is on very simple molecules, and then how to syndicate and very unstable form under the other associations that needs to with normal facility and prepare these materials, and after that the imagination doesn't stop me there. The sky is the limit, and you can go kind of even under those circumstances where you won't foresee that there will be solution, might be able to solution. And in this hope, I thought I should trigger your mind and hope sincerely that you explore various basics of this material and use it instead of doing fancy things and fancy chemistry, fancy material, and get the results which are many times better than those which are possibly exotic methods and products. Well, thank you very much for listening to me about this presentation, and I really appreciate some of you can initiate activities in this area and work out further details and make use of those applications which seem to be very Thank you very much.
So it is a very informative talk that was delivered by Professor Shamim sir. So now I request the organizing chair, Dr. Hina Hamid, to receive a memento on behalf of Professor Shamim from the chair.
I'm taking it on his behalf.
Now I would like to request Professor M.S. Alam to present a memento to the chair to Professor G.S. Kapoor sir.
शायद ले लिया हमने।
अच्छा, दे दे। नहीं आया।
ये है ना इनका आई कैसे बायोटेक वाला।
बंद करो।
ये ना, ये ना,
ये नहीं,
बुलाइएगा उनको।
पेन ड्राइव तुम्हारे पास है?
क्या?
जब तक 1 मिनट आ जाए, सेव नहीं। So now we move on to our technical session 2.
किस नाम से?
The technical session is also
ये मनोज
have 2 invited lectures.
यही मनोज क्या लगे?
Technical session 2 will be chaired by Professor Farhan J. Ahmed, Dean, Spur, Jamia Hamdard. We welcome you, sir, on the dais. Professor Farhan Ahmed, with 32 years of experience in research and teaching, has a diverse background, including 6 years at Ranbaxy Research Laboratories. His prolific work includes over 550 publications, 12 book chapters, 11 books, and a collection of patents. With an impressive citation of over 16,700 and an H index of 61 and I-10 index of 267, his contributions are widely recognized in the scientific community. He has guided more than 35 MPharm students and 43 PhD scholars, and his expertise extends to consultancy for small pharmaceutical ventures, earning him multiple awards and accolades. So it is my pleasure to introduce Professor Farhan Ahmed Saab. Now I may request Professor Farhan Saab to chair the session. So now the floor is yours, sir.
Thank you so much. Professor, and thank you to the organizing committee. After a wonderful first technical session, here we witnessed to Professor Rajesh Sarkar and Professor Shakeen Handal. I think this technical 2 sessions also have almost related subject that is emotionality and the Sandesh Srivastava. I have the privilege of introducing our learned speakers. First speaker is Dr. Manoj Guriti. He is a PhD in biotechnology and MBA in operational research. He has more than 20 years of experience in the research and development and has special interest in bioremediation, carbon dioxide management, biotechnology intervention into agricultural industries like bioaviation, bioenergetic transformations, biological wastewater treatment, biological erosion, and so on. There is a long list of more than 195 patents, incredible, also published more than 90 research papers, and he has received many awards like an MPMP award, Google Peace Book Award. Presently, he is working as a Chief Research Manager at R&D Center for Indian Automation, Hyderabad. So with this introduction, I invite you and the address of the speakers and volunteers.
Yeah, thank you, sir. Respected chairman, my seniors, my colleagues, and future scientists of this country who are sitting in this hall. I first thanks to ISAS for providing me and Jamia Hamdard providing me the opportunity to speak. I will be talking something about disposal of the waste which is generated in petroleum industry. As we all know, this is a disclaimer from my organization. As we all know that whenever there will be any production, so there will be some waste production also. And in the same way, in the petroleum industry, there are waste generation during petroleum crude production as well as during processing of the crude to make different products like petrol, diesel, and other things.
So the oil extraction portion in petroleum industry is called upstream sector. In upstream sector, we get a drill cutting, we get lot of oil spills also. Similarly, in the downstream, where like our refineries, we get lot of tank bottom sludges. यदि आप लोगों ने कभी मथुरा की तरफ या पानीपत की तरफ गए होंगे, तो आपको बहुत बड़े-बड़े से टैंक दिखाई दिए होंगे हमारी रिफाइनरी के प्रीमिसेस में, जो सड़क से भी दिखाई देते हैं। उनमें हम बहुत सारा जो डीजल पेट्रोल आता है उसको कलेक्ट करते हैं, और जिनसे वो बनता है उस क्रूड को कलेक्ट करते हैं। तो जब वो क्रूड और ये डीजल या पेट्रोल उसमें कलेक्ट होता है, तो उसमें एक सेडिमेंटेशन की एक टेंडेंसी होती है। तो वो टेंडेंसी होने की वजह से वो सेटल होके बॉटम में कुछ पोर्शन जमा हो जाता है, जिसको हम बोलते हैं ऑयली स्लज। तो ये ऑयली स्लज जो है एक ऐसी चीज है जो हमेशा अनअवॉइडेबली जनरेट होगी, किसी भी पेट्रोलियम रिफाइनरी हो या अपस्ट्रीम में हो। तो अभी तक जो मेथड थी, उसमें मेथड हम करते थे, उसको जला देते थे। जलाने के उसको इंसिनरेशन कहते हैं। इंसिनरेशन के प्रोसेस में बहुत सारा ऐसे इन्वायरमेंट को पोल्यूटिंग चीजें निकलती हैं, क्योंकि उसमें पहले पॉली एरोमेटिक हाइड्रोसाइक्लिक हाइड्रोकार्बन्स होते हैं। इसमें और सारी चीजें होती हैं, यदि वो जल के इन्वायरमेंट में जाती हैं तो इन्वायरमेंट को अफेक्ट करती हैं। और यदि हम इसकी कंट्रोल बर्निंग करते हैं, या हम इसको इस तरीके से बर्न करते हैं कि इससे जो भी पोल्यूटेंट आए उसको हम रिकवर करें और उसको फिर डिस्पोज करें, तो ये बहुत कॉस्टली प्रोसेस हो जाती है। और एक दूसरी प्रोसेस है स्क्योर्ड पिट। क्या करते हैं, इसको कुछ लैंडफिल साइट्स होती हैं जिनमें कि इनको एक बहुत बड़ा सा हम एक स्ट्रक्चर बनाते हैं, जिसमें कि हर इस बात की कोशिश की जाती है ये स्लग जमा हो तो ये जमीन के ग्राउंड वाटर को कंटामिनेट ना करे। तो उस प्रक्रिया के लिए हमें हमेशा बहुत सारे स्थान की जरूरत पड़ती है। तो there is an issue in economics and logistics of treating this waste by this method. So just one question may come: how the sludge is formed? Sludge is formed because of the basic chemistry underlying the sludge formation involved settlement and sediments of the heavy paraffin backsage, aspartins in solidified and crystalline forms, and entrapment of the water, dust, sand, metallic and other contaminants which can produce this sludge. What the sludge contains is, sludge contains volatiles like benzene, toluene, xylene. It contains phenol and phenolics. It contains lot of PAH. It contains heteroorganics and heavy metals. So generally it's considered that every 500 tons of the crude process produces 1 ton of the sludge. So existing inventory of the oily sludge is more than 1 billion tons, and in India around 20,000 million metric tons sludge is produced per annum. So there is a need to dispose it in a very environment friendly manner. The method should be environment friendly. The method should be easily adaptable by the industry. Moreover, because the sludge is characterized as a hazardous waste, so this waste, whatever method we will use for its disposal, should be acceptable to the regulatory bodies also. So, and it should have no environmental and human health impacts. It should be cost effective, and it should avoid future liabilities. Like if you are storing the sludge, it is a future liability. You are not destroying it, you are keeping it for the future. So we have to have a method which is not leaving any future liabilities. One interesting thing I would like to tell is that this oily sludge is a hazardous waste as per MOEF. Any hazardous waste disposal is responsibility of its generator. Even though if we have given a contract to a third party to destroy it, if anything happens, the liability will go to the generator. So there is need to be a precise method for its disposal. So we look on the biotechnology, as Sarpal sir has given a lot of detail about how the microorganism can be used for different purpose. Here, these microorganisms, some of the microorganisms, very specific microorganisms, are being used for disposal of that oily sludge. That intervention is called bioremediation. In the bioremediation, what happens? These microbes eat up the oil and other organic portion present in oily sludge, leaving it non-toxic, leaving it environment friendly product at the last. What is formed during bioremediation is only CO2 and water. So all oil and other contaminants are eaten up by the microbes. It is like a natural incineration. As per the cost is concerned, it is considered very cheap than other method. Incineration per se cost around $4,000 per ton disposal cost, while bioremediation is considered around $100 per ton disposal cost. So it is cheaper also. So how did it happen? There are the oil-eating microbes. They need oxygen. They need oil. They need some nutrients for their growth, and they use this sludge as their food and eat it up. So bioremediation, whenever we do, there are two types of the approaches. One approach where we add some specific microbe from the outside, that is called bioaugmentation. Other is biostimulation, where because microbes तो सब जगह पर हैं, इस कमरे में भी हैं और उस स्लज में भी हैं और सारी जगहों पर हैं. हमें क्या करना है? हम एक राइट इन्वायरमेंट दे दें, राइट फूड दे दें, जो उसमें माइक्रोब अवेलेबल हैं वो अपने आप ग्रो करें और स्लज को डिग्रेड करें. एक मेथड ये हो सकती है, उसको बोलते हैं बायोस्टिमुलेशन. पर जब हम एक इफेक्टिव अप्रोच की तरफ जाते हैं तो हम दोनों को मिक्स कर देते हैं, बायोस्टिमुलेशन को और बायो एग्यूमेंटेशन को मिक्स कर देते हैं, तो जिससे कि ये फास्टर हो जाता है. जो उसके जो इन हाउस माइक्रोब्स होते हैं वो भी काम करते हैं, और जो हम स्पेशलाइज्ड माइक्रोब डालते हैं वो दोनों भी काम करते हैं. तो अब मैं जो हमारे यंग जनरेशन यहाँ पर है उनको बताना चाहूंगा कि इंडस्ट्री में जब हम कोई काम करते हैं या कोई भी समस्या हमारे सामने आती है तो हम कैसे उसको करते हैं और कैसे मिड कोर्स करेक्शन भी करते हैं. ऐसा नहीं है कि कोई भी प्रोसेस अपने आप में परफेक्ट होती है. हर प्रोसेस के अंदर कुछ ना कुछ ऐसे शॉर्टकमिंग होती हैं which need with time to be improved. So what we did is we collected the waste from various refineries from the various locations. We characterized it. We have a very fantastic analytical facility in R&D center. Starboard are sitting here, Dr. Sarpal, Dr. Kapoor, Madam Anju Chopra, and Dr. Patel. They have many others, young scientists also. They have done meticulously, they have characterized the waste. We found that what sort of contaminants are there which need to be removed. Then after that, we found that what type of microbe is needed to degrade them, basically. And we want that while microbe degrading them, they should not make any toxic component. They should make only water and CO2. There should be no intermediate which is toxic, then is parent higher than the parent or lesser than the parent or molecules. So this work is also done by our analytical scientists. They have characterized what sort of molecules are formed during degradation of the hydrocarbons. After that, we selected these microbes. We found that a single microbe cannot do the work. So we have to mix them. We have to benefit from their synergy, so that some microbe can degrade some particular type of the component, and then some others, and some can degrade to some stage. After that, other microbe can take it up. That is called development of consortium approach. That's what we did. Then we optimized the process at the lab. After application, then we found that if you are going to the large scale implementation of this process, how can we grow these microbes? Then how can we grow the microbe is the lesser cost, and how can we make them transportable? Means suppose यदि मुझे फरीदाबाद के अंदर बैक्टीरिया डेवलप करना है, मुझे उसको यदि चेन्नई भेजना है, तो मैं कैसे फॉर्म को उसको भेज पाऊँ? यदि मैं लिक्विड फॉर्म पर भेजूंगा, तो it will be a difficult sort of exercise for me. So we have developed that. Then we did large scale trials. Then we optimized the monitoring tools, how we will monitor the success. Then we did the toxicity testing. Then we fine-tune the process. Then we bring it to the commercial level. So, but before going commercial level, there is a requirement of regulatory approvals. Before that, when we introduced this bioremediation, there was no regulatory approval from CPCB or MOEF, where bioremediation can be used as a tool for disposal of oily sludge. And what we did, we approached with all scientific documents to CPCB that yes, we have developed this method and this has these things. They had a lot of scientific discussion. Then they give a concern letter to all state pollution control board, because CPCB being a regulatory authority doesn't never give a direct approval to any process. They suggest their state pollution control boards. They are the approving authority. They suggested that they given the advisory letter to all state pollution control board. If any application comes where bioremediation is being used, with some conditions, you should allow it and you should accept it. That's what we did. After that, we developed the process and we brought it to the field. What happens? जब एक बायोरेमेडिएशन में हम कोई भी माइक्रोब यूज कर रहे हैं, जब भी हम कोई माइक्रोब यूज करते हैं, माइक्रोब एक लिविंग बीइंग थिंग है, तो हमको ऐसी कंडीशन बनानी पड़ेगी जिससे कि माइक्रोब प्रॉपर्ली ग्रो कर पाए। तो यदि मैं कहूं कि एक सिस्टम कॉन्सेप्ट है जिसमें कि जो परफॉर्मेंस है ये कई चीजों पर गवर्न करेगा कि वहां का टेम्परेचर कितना है, हमने हाइड्रोकार्बन का लोड कितना डाला है, वहां का न्यूट्रिएंट स्टेटस कितना है, क्या कि वहां की जो स्लज है या सॉइल है वो माइक्रोब की ग्रोथ को कोई उसमें ऑलरेडी कोई इनहिबिटरी कंपोनेंट तो नहीं था। इस सारी चीजों को देखते हुए हमने इस सिस्टम को सब देखा, एक बैलेंस बनाया, उस बैलेंस के बेस पर हमने इसको फील्ड में अप्लाई किया। जब हम लार्ज स्केल पर अप्लाई करते हैं तो हमको टाइम पर उसको मॉनिटर भी करना पड़ता है। फिर हम देखते थे मंथली कि इसमें माइक्रोब की एक्टिविटी कैसी हो रही है, फिर हम देखते थे कि टोटल पेट्रोलियम हाइड्रोकार्बन कैसे घट रहा है, जो हैवी मेटल है वो नीट स्लज में कितना था, जो सॉइल हमने यूज करी थी बायोरेमेडिएशन के लिए उसमें कितना था, आफ्टर कंप्लीशन ऑफ ट्रीटमेंट ये कितना रहा, ग्राउंड वाटर में क्या फर्क पड़ा, उसके लिए हमने पीटोमेटिक बेल लगाई। और हमने फिर जो आफ्टर बायोरेमेडिएशन जब ऑयल उसमें से पूरा चला गया तो हम देखते थे कि जो बचा हुआ सॉइल है क्या उसमें कोई टॉक्सिसिटी तो नहीं है, ऐसा तो नहीं है कि ये कोई ऐसा मेटाबोलाइट बना हो जो ज्यादा टॉक्सिक हो। वो हम स्टेब्लिश करके जब वो सेफ होता है तब हम उसको बायोरेमेडिएशन के लिए हम उसको मानते हैं कि ये स्लज जो है बायोरेमेडिएट हो गई है। आफ्टर दैट कई बार ये सवाल आता है कि उसमें हैवी मेटल्स भी होते हैं। कुछ हैवी मेटल तो ऐसे हैं जिनको माइक्रोब भी न्यूट्रलाइज करते हैं, जैसे क्रोमियम है और साइनाइड है, लेकिन कुछ ऐसे होते हैं वो जो जमीन में रह जाते हैं, यदि उसको निकालना हो तो फिर हम उसमें कुछ ऐसे प्लांट की ग्रोथ कराते हैं जो कि उस हैवी मेटल को अपटेक कर लेते हैं और उस जो प्लांट मटेरियल को फिर कंट्रोल कंडीशन में बाउंड करके हम उसमें से हैवी मेटल्स को रिमूव करते हैं। एंड जो ये हमने टेक्नोलॉजी बनाई, ये हमने पूरे अपनी रिफाइनरी में जितनी भी हमारी 10 रिफाइनरीज हैं उनमें हम यूज करते हैं। हमारे मार्केटिंग लोकेशन जहाँ से हमारे पेट्रोल पंप में प्रोडक्ट्स आते हैं वहाँ भी स्टोरेज होता है, वहाँ भी जो स्लज बनती है उसको भी हमने किया। तो इसके बेस पर हमको बहुत सारे प्राइज मिले हैं, जिनमें NPMP अवार्ड है, जिसमें यूके का टेक्नोलॉजी अवार्ड है और बहुत सारे अवार्ड हैं। ये पूरी टेक्नोलॉजी हमने हर स्टेज पर पेटेंट की है। इसको जैसे ही हमने माइक्रोब बनाया हमने माइक्रोब पेटेंट किए, जहां जहां प्रोसेस स्टेप में हमने इनोवेशन या इनोवेटिव स्टेप था वो सब हमने वेल पेटेंट प्रोटेक्टेड है। It was widely covered in the media also at a different time when we use it for different purposes across the country. तो मैं कुछ केस स्टडीज की पिक्चर आप लोगों को दिखाना चाहूंगा। ये देखिए, यदि मुझे लग रहा है कि पिक्चर बहुत क्लियर नहीं है, फिर भी आप देखेंगे तो पहले जो काला था आफ्टर बायोरेमेडिएशन वो it is become brown actually. Similarly, these are some pictures, and this is what we did at ADNOC Abu Dhabi. This is what we did at Paradeep oil spill. This is what we did during Mumbai oil spills. This is what was done after Chennai oil spill, and this all basically wherever is sludge we did the bioremediation. अब जब हमने इतना बायोरेमेडिएशन में 10-12 साल काम किया तब हमें एक चीज महसूस हुई कि जब भी हम बायोरेमेडिएशन करते हैं, कभी बारिश हो गई, या टेम्परेचर बहुत कम हो गया तो प्रोसेस अफेक्ट होती थी, उसको ज्यादा टाइम लगता था। देन वी थॉट, और कई बार क्या होता था कि जो हमें लैंड चाहिए होता है, जब हम बायो रेमेडिएशन करते हैं, जैसे आपने पिक्चरों में भी देखा होगा, वो लैंड में किया जाता है। दैट चंक ऑफ लैंड इज अनयूटिलाइज्ड। टुडे द लैंड इज वेरी बिग asset, so that no refinery can afford that lot of land is being used for bioremediation for long time. So ये सारी चीजें थी, और इसमें बार बार रेगुलेटरी अथॉरिटी पूछती थी, जो ग्राउंड वाटर कंटामिनेशन रोकने के लिए हम सारे प्रिकॉशन लेते हैं, सब कुछ करते हैं, स्टिल इट इज ऑन द आई ऑफ द all those bodies basically. So we again discuss internally, then we found what should be done. Then we come up with a new technology. Still it is working. If anywhere there is oil spill where you cannot collect the suppose the oil spill happens in any sea or in any land, you have to treat it there only. But the oil sludge where there is lot of inventory is available in the refinery, then what can we do is we can develop a reactor where this sludge can be put. Earlier it was taking 3 to 6 months. We develop a technology which can take 4 to 5 weeks. Within a reactor, we provide all the conditions so that it can be quickly degraded by the microbes. What we did is we developed this technology, and we found that within very less time we can degrade all the oil, and only the sand is left. It has been implemented in almost in our most of the refinery. And these are some pictures how we did it. This is the reactor was developed in our Barauni refinery. This was developed in our Panipat refinery. This is developed at our Gujarat refinery. This all. So what was the benefit is? Benefit is it is a very faster. It takes very less time because we are giving control conditions so that better degradation can be achieved. There is no impact on the natural disturbances. If rains happens, we have already put a छत, इसके ऊपर एक छत बना देते हैं तो कोई पानी जाता नहीं है, तो रेन का कोई इफेक्ट नहीं पड़ता। टेम्परेचर कम होता है तो हम टेम्परेचर बढ़ाने का प्रोविजन रख लेते हैं, तो यू कैन डू इट वेरी फास्ट. So that we did, and there is no VOC also because we have put a procedure for the VOC collection and is treatment also in the same system. So this is done. We found that it is a very cost effective and very fast technology. So then what I want to say to our young scientists is that we develop a technology. After due course of the time, we understand that there are some improvement is required. We did that so that it is a continuous innovation happens in the industry. Whenever we do any research, anything, we should also take in our mind that this research is maybe perfect for today, but tomorrow there will be a better version of this. So we should always look our technology for further improvement. With that, I would like to conclude that bioremediation is a very cost-effective method. Bioremediation process requires which method we should use is depend upon the case basis. It needs a proper management. Being any biological method always require a proper management. We have to give a good condition for their growth. And IOCL bioremediation technology can treat all type of the oily sludge very effectively. Thank you very much.
During the lunch hour. Now I request the chair to honor the speaker with a moment. I love you. ये रख देना दूसरा.
Our next speaker of this lecture session, Dr. Sandeep Srivastava, and he presents online. He is a distinguished university scholar at University and Professor of Medicine, Pharmacology, Toxicology, and Biochemistry. He is also director of the NIHS Funded University of New Zealand Superfund Research Center, and his focus of his group is on to elucidate cellular and molecular mechanisms of muscular inflammation, atherogenesis, and examine how these processes are affected by environmental pollutants and chemical products. His lab extensively uses mass spectroscopy, post-atomic cytomics, chemical chemistry, analysis, pathology, and analytical assays. He has also established with his processes. He has served as a chair or member of more than 50 NIH study sections and as a member of the editorial board of circulation research. With this introduction, I invite him.
Focus of my work is right now examine the case of vehicle cardiovascular disease is the leading cause of death associated with environmental exposures. The world the children because of the environmental exposures and heart disease death. And as you can see in the map on the left-hand corner, most of these cardiovascular diseases are associated with skin and heart disease, and with the exception of China, where stroke is the leading cause of death associated with vascular complications. So, the underlying cause of most common cardiovascular disease is fibrosis, which is essentially buildup of what's called immune cells in the body. So in the healthy individuals in the early stage of their lives, we have partly with normal position. As we age or we get exposed to various conditions which are deleterious to health, especially cardiovascular health, you see the accumulation of lipids in the arteries. And as this plaque progresses, you also see the proliferation of the immune cells. And at the later stages, these immune cells lead to a destabilization and rupture of the plaque, and which leads to a heart attack and stroke. And about 70% of all the heart disease are associated with onset of atherosclerosis. So atherosclerosis is the driver of more than 2/3 of the heart disease. And it's interesting to note that only humans get atherosclerosis, animals don't. Even our closest ancestors, chimpanzees and gorillas and so forth, they don't get atherosclerosis. With chimpanzees, we share about 97% of the genome. But the incidence of atherosclerosis is only 18%. Whereas there are other cardiac complications, but there's no atherosclerosis. Which asks the question, why does atherosclerosis occur in humans in the first place? And the answer is about 60 to 80% of heart disease and diabetes is the driver of several heart complications and environmental. When we're talking about environmental nature, we're talking about not just the environmental nature per se, but nutrition, like diet, smoking, or weight for that matter, air pollution, physical inactivity, circadian rhythm, and change in environmental conditions, which is very prevalent right now with climate change. All the toxins which are generated by air pollution, we are interested in volatile organic compounds. The reason being that these are very reactive molecules, and in some cases examination results and and that needs to not that's what comes to the overseas. You can see that about 20% of them are LEI and 25% are denied and when we look at the sources of VOCs, then we can find that, as I said, VOCs are generated by combustion. So the tobacco is generated by VOCs. Baby also generates some of the VOCs on industrial sources are major contributor to VOC generation. Wildfires generate a lot of VOCs like activated benzene are very high concentration by wildfires. Powerful exhaust generating VOCs. And the VOCs are also abundant in household products and cosmetics. And some of the VOCs are also generated by heat and water. So it's not that we are just getting VOCs from outdoor air, but we are also getting exposed to VOCs in the indoor environment through household products or through VOCs are also associated with some of the chemical storage accidents. And that's why it's really important to understand the toxicity of these chemicals, because we get exposed to large quantities of these volatile compounds and conditions where you have accidental exposures. On the left side, you see vinyl chloride vinyl chloride followed by explosion of vinyl chloride. And then on the right side, you see the little element of the fake arsenic butadiene. So it's very important to understand even the high dose toxicity of these chemicals, so we are very prepared for disaster management. So some of the molecules that we are studying, and I'm going to share the data today with you, are activated and straight-chain molecules, very reactive molecules, primarily generated by combustion. And benzene and xylene generated by petrochemicals, butadiene, Harvard University, and vinyl chloride and trichloroethylene, fluorinated alkenes, and these are industrial sources, are major sources for the original chemicals. So we have generated or established methods and methodologies for quantification of molecules by various ways. One is on the left side is our nano-chip technology, and the dominant goal is to have a chemical device where you can have a wristband or a cell phone or whatever to really quantitate this exposure. Here we have that on a chip where we can play them with nanoparticles and play them with the cloud. We can quench some of these VOCs, and on the bottom now we see some of these VOCs generated with a system of VOCs generated by this methodology. On the right side, we show our portable GCMS that we built in-house on in-field monitoring both for the indoor and outdoor air. And this portable GCMS can be put in the front of an electrical vehicle and define neighborhoods to measure its levels. The personal exposures, we look at the metabolites of these chemicals. We just published a paper in Environmental Scientific ecology, which was picked up as the other article, where we looked at the phase 2 metabolites of xenolime exposure in humans. And so these molecules, these chemicals, are excreted and inhibited in forms of lactic acid, chloric acid, glycine, sulfates. So we do both at the environment monitoring at the environment level as well as exposures. And our experimental design is to enroll 1,200 subjects to this study and then do the prospective study. We do a lot of physiological measurements, biochemical and methodological measurements, chemistry functions, and for the exposure assessment, we look at the environmental level, both at the air as well as in the wastewater, and then on the person exposure, we look at metabolites in the urine. Human studies can only establish the association in order to get best possibility that any given disease is sufficient to cause the disease effect. We do the full animal studies where animals are exposed to a single chemical, and we look at various markers of injury or pathological environmental changes in the animal. And we value those which is X diet and species, and then tease out the underlying cellular and molecular mechanisms. So here now I'm going to share some of the data associated with human exposure to VOCs. So first, we examine the effect of VOC exposure on blood pressure. And what we found that in our cohort, acronym was associated with increased systolic blood pressure. After increased formation of acronym metabolite was observed in the unit associated with. We also observed that acronym and uterine metabolites were associated with impairment of vascular function as assessed by arterial stiffness. So this was our discovery cohort. Now, to confirm these observations, we also looked in a different cohort, the association of UC exposure with blood pressure, and what we found that in Jackson Heart cohort, which is a cohort of 1,200 subjects with data on atherosclerosis, function, and so forth. So we measured the uterine these particles, and we found that the acronym metabolite PHPA was associated with increased blood pressure, and this is for as well. So that's confirms our initial finding. Because the exposure was associated with compromised function and blood pressure, we focused our previous studies on endothelial cells. The reason being that endothelial cells in blood vessels not only separate the blood from the other organs, but they stimulate a lot of vascular function. The vascular function, the blood pressure, they are involved in the recruitment of inflammatory cells in pathogenesis. They are involved in angiogenesis, which is formation of blood vessels. So this slide which gives you a snapshot of some of the data associated with endothelial processes. And what we found that microparticles of which are generated by either the activation of the endothelium or the fusion of it by this exposure. And when we have this velocity, these microparticles are shed from the endothelial cells and they appear in the blood. And then you can measure the particles. So again, we found association with several VOCs, but we wanted to point out that acronym and benzene metabolite would be associated with decreased formation of blood myocarditis. And complementary data was obtained with circulating antigenic cells. These are the cells which are involved in the repair of the blood vessels. Anytime that engineer the mechanism to repair them, but in this case, what we found that is exposure depleted these antigenic cells. So not only they cause the toxicity, they also compromise the ability of the separating antigenic cells to heal and heal, which will lead to prolonged toxicity. We also observe that this exposure, in this case, active metabolic PHMA, metabolic HBD, and metabolic PHMA. These were associated with these MCP1 and IL-8, which are chemotherapy molecules that would associate with the treatment of immune cells with almost every space, and HCRP, which is a marker of systemic inflammation. So I think we should have all of those also associated with some funds we don't know complementary data, we also observe that white blood cells with exposure, suggesting that exposure also causes inflammation. To examine the effect of the association of this exposure with angiogenesis, we look at Genesis Parkour because they have longitudinal data on angiogenesis years. And here they show the data of probably classification is so what we found that active and normal were the two molecules which were strongly associated with angiogenesis and disorder. And when we expose the antigenic mice, increase in blood protein injection mice to active, then we found that active exposure was sufficient to exacerbate angiogenesis, as seen by the regulation of the lipids in the fats. Next, I look at the BS molecules and the association of microfibers. And these are, as I said, chemical, and we found in the exception of quality, most of these chemicals are associated with separating and suggesting that human exposure to these chemicals is associated with toxicity. Again, there is a possibility that these chemicals are sufficient to separating toxicity, which shows light, either or light, and particles, and we found that exposure to these chemicals is consistent with the toxicity. In case of resin exposure, we also look at separating antigenic cells, which are involved in repair, and we found that similar to human exposure, these cells are repeated in physical mice. So these were some of the subclinical markers of association with chemicals with the next, look at what happens at the vascular level. We did two different studies, one with the heart failure and one with the other. So in the upper left panel, we are showing the and pressure over the subjective mice. And what we find that is ejection fraction, which is a hallmark of cardiac function, was decreased in the mice exposed to benzene, suggesting that benzene exposure exacerbates heart rate and is smart. In the Bennett study, and expose them to benzene for 6 months. And what we find here is the exacerbation of pathogenesis in the early round of the mice exposed to benzene. And you can see the depletion and the chronic formation and fold each size is much bigger as compared to control CPH growth. So, to examine the mechanism by which this pathogenesis and this state of lesions is happening, we look at data from these mice exposed to benzene, and what we found that in these observations there was increased smooth muscle cell numbers, increased cells, and there was increase in proliferatory cells. And when we stratified the data of proliferatory cells, we found that there were a lot of T cells. We found these were so essentially what we find that small muscle cells and T cells play a major role in benzene pathogenesis. And because this data was only at the transition level, we looked at the protein level by site. And in this case, my choice with established lesions were exposed to just 2 weeks of benzene, which is a high exposure. And what we find here, and consistently with the mRNA as a result of vaccine data, there was an increase in CD4 positive T cells and CD8 positive T cells in the mice exposed to benzene, suggesting that T cells are a major driver of the immunological changes in the body. Now, in order to track the full signaling cascade, we are developing an assay which is called mass cytometry, where on a single slide we can see for up to 40 different antibodies. So we can look for 40 different antigens in the same section, and then we can trace out the whole signaling cascade associated with this exposure. Which changes in the immune cell signaling. And going back to some of our RNC data, what we find that there was a robust interaction of some genes, in this case, one and one, and so forth. These genes are not either visible in control, but they are robustly integrated with the exposure. On the contrary, there are some genes which are prevalent in controls, but they are not found by completely with the exposure. So there's a lot going on in our lab, and we are trying to get handle these signaling mechanisms. One example of this is we are looking across the plot of our CE action. We look at the associated signaling, and here we are doing some cell chat analysis where we're looking at the action of T cells in the lymphatic and epithelial cells within the plaque, and we're looking at inside signaling coming in and signals going out from the T cells. And very also short one, we're looking at very the association of IL-2, IL-7 axis with the T cell functions. And what we find, not only this IL-7 is modulated by the exposure, the IL-7 receptor, especially in the T cell, is completely wiped out. Whereas on a monocyte macrophages, benzene has no effect. So this is telling that selectivity in the T cells, I7 is critical vital of inflammatory phenotype of the plaque, which leads to stabilization of the plaque and plaque rupture, which will be required as well. We look at the earlier stages of the lesions. We are in the field is the role. We look at the endothelial transcription of the genes associated with the exposure, in this case, with the cellular experiment with benzene metabolite. And what we found that aldehyde induced cellular genes associated with explosive oxidative stress, inflammation, nitric oxide synthesis, and ER and so forth. Was also associated with apoptosis. As an adaptive response to all these signaling, there was induction of these stress responsive genes known as pre-CHA proteins, which are driven by the transcription factor HSF1. And when we did the bioinformatics approach trying to tease out the mechanism and the association of these changes in the pathology, we found that most of the changes were associated with pathogenesis. So next, we knock down this one of the target protein, which is BA1B, in endothelial cells, and look at the expression of adhesion molecules like M1, which is the primary driver of leukocyte recruitment, and we found that exposure to benzene metabolite increased the reduction of M1, it also increased the adhesion of leukocytes, decreased ENOS, which was weighted by knockdown of HSPA1B, and exacerbated apoptosis as driven by caspase-3 activation, as well as induction of ADF3, which is a transcription factor associated with the genetic segment associated with stress. So these data suggest that activation plays a major role in terms of exerting the toxicity via oxidative stress and stress mediated mechanism and ENOS downregulation. And these processes could be directed by activation. We have now a endothelial-specific HSPA1B non-pathogenic mice to probe the role of HSPA1B protecting pathogens in vivo. And to put the whole story together, we see that indoor and outdoor air use of compounds will seem to get metabolized and included processing as an adaptive response is immunization of circulating dendritic cells on the bone level, whether it's called exposure, decrease these levels and exacerbates the processing. And an automated adaptive response is the reduction of proteins, which prevent potentially prevent the abiogenesis and response. With that, I acknowledge the contribution of my colleague in this study. This was not possible without large team of investigators and support from national institute. Thank you.
So I request the organizing chair, Dr. Hina Hamid, to receive the memento on behalf of Professor Srivastava from the chair. Now I request the conference chair to honor the session chair with a memento. Now we are going to have a lunch break now. So you all are requested to proceed to the lounge and take your lunch. So there is a separate arrangement for teachers and students at launch. So we will be assembling back at around 3 p.m. for the next sessions. I request to the next speakers of the next session, third and fourth, to upload their presentations. Again, I request the speakers of oral session to upload their presentations. Session 3 is going to be chaired by none other than Professor S. Raisuddin Sahab, Dean, School of Chemical and Life Sciences, Jamia Hamdard. Professor Raisuddin Sahab, the Dean of School of Chemical and Life Sciences, Jamia Hamdard, specializes in toxicology with a focus on environmental risk assessment and biomarkers in fish models. He has an extensive research background, including international experience in South Korea, and boasts over 180 SCI publications with more than 8,000 citations. Professor Raisuddin's commitment to ethical research practices is evident through his roles as Vice President of key organizations dedicated to alternatives to animal experiments and toxicology in India. His department is currently engaged in research programs involving disease modeling and toxicity testing using Drosophila melanogaster and Caenorhabditis elegans. So with these remarks, I would like to request Raisuddin Saab to start the session.
Good afternoon. As Dr. Shafi announced, there are 4 presentations, and all presentations are very much focused on the chemical and life sciences. So, the next presentation is by Dr. Mahipal.
T3 में.
Dr. Mahipal, Dr. Mahipal, yes. Okay. So Dr. Mahipal Yadav is going to make a presentation on the topic plausible ancestral analogs of the Krebs cycle. The CPO is presented to me. Shows that Dr. Mahipal has a very wide experience of working in academic institutions as well as the industry. Such as AI industry, which is one of the very renowned industry. And then he is currently working at the Department of Chemistry, University of Delhi. Besides, before joining this institution, he has also worked at a very prestigious institution at La Jolla, California, at the Scripps Research Institute. For those who are in Scripps, they must be knowing how to do this institute. So I hope that Dr. Mahipal will be giving an interesting lecture. And how much time?
8 minutes.
So total time is 8 minutes. Dr. Mahipal, I think you know the importance of time.
Yes.
So nothing will be precise. So 8 to 9 minutes will be the talk, and then if you have any questions, you can ask me.
Thank you so much, Professor Raisuddin, for kind introduction. So after several wonderful talks from the last session, I would like to divert your attention towards more of kind of philosophical topic that we are trying to address with chemistry. And the broad topic is origins of life, and the concise topic is a plausible ancestral analog to the Krebs cycle. So you all know that Krebs cycle is central to our metabolism. Yeah. This is working now. It's working now. Yes. Again, it is stuck.
आप इसकी तरफ स्क्रीन की तरफ भी करते हो अब ऑनलाइन
Okay, yeah. Okay, thank you. So so if we look into today's modern metabolic pathways, it looks more complex than Delhi itself. It is highly complex. And if you consider this as Delhi, then this portion looks like CP of Delhi. And indeed, if we see, this is citric acid cycle. It's very important metabolic pathway to provide energy in the current living systems. Okay, so if we zoom in this portion, it looks like this. Okay, it looks like this. So it actually degrades citric acid cycle all the way to oxaloacetate by several metabolic intermediates, and it produces the energy in the current living system. So, but if we go back and if we analyze the genomic and metabolic analysis, it suggests that a precursor to the modern PCA cycle existed at the origin of life stage, probably in an anabolic role. So current citric acid cycle is catabolic. It degrades the 6-carbon molecule to a 4-carbon molecule. So it is catabolic in nature. But currently, when life originates at that time, before life, it is suggestive that it was anabolic in nature. So we are generating the citric acid cycle instead of degrading it. And if you look into this picture, it will be more clear, because the formation of Earth was around 4.5 billion years ago, and then life originates around 3.8 billion years ago here, and then the oxygen came into the atmosphere around 2.5 billion years ago. So it says that when the life originated, there was no oxygen. So the atmosphere was completely reductive. There was ammonia, there was carbon dioxide, there was methane, there was hydrogen, but no oxygen. And we have to make the molecules of the life in absence of oxygen. So this is the comparison. And indeed, if we look into some of the primitive organisms like the cyanobacteria, we have this citric acid cycle running in the reverse direction, exactly reverse direction. So if we see the citric acid cycle in the anti-clockwise direction, then the reverse one is exactly same molecules but in the clockwise manner, and it is producing citric acid from oxaloacetate. So many scientists in that area are trying to reproduce these cycles without using the enzymes, because before life there was no enzyme. All these reactions should be catalyzed by several minerals, but it should be without any enzyme. Okay, so but there is no success. So we thought, like, we looked in very carefully in the citric acid cycle, and we find out that there are several keto acids in this cycle. You see alpha ketoglutarate, oxaloacetate, all the other intermediates are simple carboxylates. Okay, and these two are the keto acids. So we thought that there should be some reason why these intermediates or why these keto acids are there. And if you see, I would like to mention one important point here. If you see the acidity of the acetate and its keto acid analog pyruvate, there is a huge difference in the acidity of the alpha protons. These CS3 protons are highly activated or highly acidic in comparison to acetate because of this ketoenol tautomerism, which is very favorable in case of the pyruvate. So we took advantage of this acidity and we thought that if we can start with the simplest keto acids, what will happen? And that another important thing I would like to highlight here is there is some another role also these keto acids are playing. They are helping in the synthesis of the amino acids in the biological systems. So oxaloacetate will help in the formation of aspartate, which will ultimately lead to the formation of other intermediates like the uridine or cytidine triphosphates. And similarly, the alpha ketoglutarate will make the glutamate. So with this idea, we started with two of the simplest keto acids, one with hydrogen and another with methyl group. And we mix both of these keto acids in water because on early Earth, there was no other solvent. So only water and pH was around neutral. So we mixed these chemicals and what we observed that these molecules underwent an aldol condensation. So CS3 will attack on this aldehydic group of the glycosylate to make the simple aldol product, that is malonyl formate. Then it dehydrated because of that keto group to make the formyl formate, and then this molecule get reduced to the alpha ketoglutarate. Then it underwent another aldol condensation with a molecule of glycosylate to produce the isocitral formate. Then it underwent the dehydration towards the aconityl formate formation. And similarly, if the two molecules of oxaloacetate are condensing, then it will produce the citrul formate. So these reactions look simple if we look like this. But when we compare these reactions with the modern reverse citroacid cycle, you will be surprised that we produce the exactly keto acid analogs of the canonical reverse citric acid cycle. So citric acid cycle starts with oxaloacetate. So we started with oxaloacetate or with this one. In both cases, we are producing the same product. So first product we are producing is malonyl formate, and biology produces malate, which is so we are producing the keto acid version of this malate. Second, biology produces fumarate, we are producing the fumaroyl formate. Biology produces succinate, we are producing the keto acid intermediate alpha ketoglutarate. And alpha ketoglutarate biology also uses. And then biology is producing isocitrate, we produce the isocitral formate. And biology produces aconitate, we are producing aconityl formate. And remember, we did not use any catalyst or any enzyme. It is the simple reaction, and it is remarkable that we are producing the exactly same keto acid version of the canonical citric acid cycle intermediates. So I would like to highlight the mechanism of this conversion. Actually, from this fumaroyl formate, there is a reduction of the double bond towards the keto acid alpha ketoglutarate. So this could happen either via the cross kinase or hydride transfer reaction. So glycosylate will transfer the hydride towards at this beta position, like a Michael addition, or it can make the diadact of the pyruvate and glycosylate to make this di-HKG, then dehydrate, and then it will underwent this reverse Claison's fragmentation, retroclaison's fragmentation to produce the alpha ketoglutarate. So this way, we produce the exact same keto acid analog pathway which could have existed on the early Earth. And when oxygen came into the atmosphere, these keto acid intermediates can degrade to the canonical intermediates. So this keto group will be removed, in presence of the oxygen or hydrogen peroxide as the carbon dioxide, and it will produce the same intermediate that biology is using. So with this, I end my talk, and I would like to thank the main man behind this story, Professor Ram Krishnamurthy, my postdoc advisor, and our collaborator, Professor Greg Springsteen. I would like to thank Scripps Research for the opportunity, and then the funding agencies, NASA and SFCC. And I would like to thank Jamia for organizing this wonderful event, and Delhi University to provide me the opportunity to attend this wonderful event. Thank you so much.
Sometimes very basic research is missing in many lectures. So that's why I conducted very fundamental pathway of the cell. Very nice lecture. I think questions have also quick. Audience, if they have any query.
I would be happy to answer any questions.
Any questions? हो सकते हैं frankly.
How many years does it took?
आप पूछना चाह रहे थे?
So this particular project took around 2 years.
ये काम अभी continue कर.
Yeah, actually we did extended this work, and we produced 2 another papers, very nice papers, on the extension of this work. And currently we are working on the enantiomer selective synthesis of the amino acids, because biology produces only one isomer, L enantiomer, not the D, for the amino acids. So that is currently we are working on.
Pre-biochemistry has published in Nature Chemistry.
Very, I think, nice and exciting work. And keep on doing good work with us.
Thanks a lot, sir.
So much.
Thanks a lot, sir. Thank you so much.
PI industry के इसलिए आ रही है कि share बड़ा महंगा है.
Yes, sir. Okay. Thank you, sir.
So
Thanks.
we have the second lecture by Bhavna Mattu. Right? Bhavna ji?
Yes.
Okay. So she is working at our medical college, Delhi, under the Institute of Medical Sciences and Research, in the Department of Physiology. She is assistant professor there, and she has also experience of working at Anand International Medical Sciences to make a resident doctor. And then she worked on the neuromodulation in chronic pain disorders. She is a very active researcher, and for her MD thesis, she has got a very prestigious award, that is P.K. Anand Gold Medal for
ये बोलम कर रहा है शेयर में.
given by SMR
AIMS, New Delhi.
in AIMS. So, I will be speaking on the topic of antioxidant effects of Pterocarpus marsupium
ये वाला ना?
on the high fat diet in the global model of atherosclerosis. So, must be very exciting lecture. बस 10 मिनट है आपके, so you speak your talk, so you know the importance of time.
Just a minute.
Okay. Yes.
दोनों साइड से. You can use hand mic if you wish, otherwise this podium mic.
Thank you, sir. Thank you for the kind introduction, and I would like to thank the organizing committee for such a wonderful opportunity to present my work. So this work we've done in Jamia Hamdard, the antioxidant effects of Pterocarpus marsupium, or commonly known as Vijay-Sar, its heartwood extract on high-fat diet-induced rodent model of atherosclerosis. So the word athero comes from Greek, meaning porridge or gruel. It's basically when porridge or gruel, it's good to eat, but when it's in your arteries, it's bad. So atherosclerosis is basically the accumulation of this fibrofatty lesion in the arterial wall, and it's a cause of major mortality and morbidity. In fact, when we look at the global prevalence of diseases, the contribution of cardiovascular diseases is the maximum in the non-communicable section, and 30% of these are generally attributed to
pathogenesis of atherosclerosis. So it is atherosclerosis which is leading to either ischemic heart disease or stroke or cardiomyopathy, and some cases of arterial fibrillation. And especially it's important in lower and middle socioeconomic status countries like India. Like in the morning lecture, Professor Sanjay mentioned that it is air pollution, but primarily it is also our diet. So the problem with atherosclerosis is generally the patient does not present till the lesion is developed. And where the lesion is, depending on that, the symptoms will vary. If it is in the coronary arteries, it will be patient will present with MI or heart attack, commonly known as. It may be in the peripheral arteries where you will get intermittent claudication or maybe different sites of the blood vasculature. Now, during the first insult to the vessel and as this lesion progresses, there are some factors: coexisting diabetes, coexisting hypertension, dyslipidemia, or any inflammation, ongoing inflammation. This will make the proliferation faster and make the process faster to reach into a symptomatic stage of atherosclerosis. And if you look here, this is the healthy blood vessel. So first, with the lipid, there is a buildup of atheroma on which it calcifies, and macrophages and all the chronic inflammatory cells add on. So the treatment currently is if there is an underlying cause, to treat that in terms of lipid lowering drugs or antihypertensives. And once the patient presents with an MI, we only try to revascularize the coronaries. So there is a need for some sort of a preventive care in, decreasing, at least delaying the progression of this particular problem. Now, Pterocarpus marsupium is an Indian plant and very commonly found in central and southern parts of India. There are known reports of it preventing cataract. It is an accepted anti-diabetic, and antioxidant and anti-inflammatory effects were also have been reported with this plant. Now, with this in mind, we hypothesize that probable intervention of Pterocarpus marsupium heartwood extract in high-fat diet model of atherosclerosis might provide us with some sort of an add-on therapy or primary therapy for preventing the progress of atherosclerosis. So our first objective with that in mind was to study the anti-atherosclerotic activity of the heartwood extract in the high-fat diet-induced atherosclerotic model, and we are also studying the antioxidant effect of the herb. Now, we had, after calculation of the sample size, we basically divided the animals on two major subtypes of N18. One was on standard pellet diet and the second one was on high-fat diet for 2 months, which was then given vitamin D of 60,000 international units for 3 days for the accentuating of the plaque buildups, so that the atheroma calcifies. And so these were our control animals, with group 1 of 6 animals each, not receiving any drug, standard control. Group 2 received atorvastatin. Atorvastatin is a standard hypolipidemic drug, and it is given commonly for dyslipidemias. And the third group, we gave Vijesar. And in the high-fat diet group, which was our atherosclerotic model, we gave similarly, one was the control, one was given atorvastatin, and one was given Vijesar. So these groups were then pre and post divided, and we studied the oxidative stress markers, MDA, nitric oxide, superoxide dismutase, and for the lipid profile, we studied the high density lipoprotein, triglyceride levels, total cholesterol levels in the serum. So after the first 2 months of giving the animal high-fat diet, we had to establish whether atherosclerosis was actually developed in the animal or not. And this is a normal artery, normal aorta. And you can see the normal endothelial cells, normal intimal thickening is seen. And there is no, the adventitia looks normal. But in the second micrograph, you can see these are the high-fat diet groups. You can see that there is intimal thickening. There is the smooth muscle architecture is it's deranged. You can see their vascular cells are also Here they are losing their layer-like structure, and there is presence of foam cells. So this is indicating that atherosclerosis has set in and that the model was successful in establishing this model. Now for our this is our groups who were given high-fat diet and were given standard drug atorvastatin, and the second group was given this Vijay-Sar heartwood extract. And we can see that in the first, the high-fat diet control, you can see there is intimal thickening, and this is reduced in the atorvastatin group. And although you can see foam cells in the Vijay-Sar group, but there is a reduction in the lesion size. So there are some reversal of the pre-atherosclerotic changes by giving Vijay-Sar also, which is comparable to the atorvastatin group. When we looked at our results for triglycerides, the triglycerides are the main initiator of the insult. We found that there was significant reduction of triglyceride levels in the high-fat diet versus the Vijay-Sar group. So you can see this, and there is the high-fat diet group. There is a reduction in the triglyceride levels. The total cholesterol levels, although we did not get any results, significant results for Vijay-Sar, we saw that the high-fat diet group with atorvastatin, there was a reduction in cholesterol, and this is a standard known fact also. Also, you can notice the normal control versus the high-fat diet group. So in atherosclerosis, there is also dyslipidemia, which can be seen here. The high-density lipoprotein is protective against any dyslipidemic conditions. And here we saw that Vijay-Sar has increased the HDL levels when compared to controls. And this is significant in the Vijay-Sar group. Now, when we looked at the nitric oxide levels, we did not, these were assessed using standard spectrophotometric techniques. We just found significant decrease in the normal control versus the atorvastatin normal group. Perhaps which says that atorvastatin, which commonly done is given also before atherosclerosis sets in. So it is given generally when you present with dyslipidemia, so it has a role in preventing the acceleration of the lesion. Results with malondialdehyde show us that there is a decrease in the high-fat diet group versus the Vijay-Sar group. So there is some antioxidant activity. With superoxide dismutase, there was no particular result seen with Vijay-Sar, although we saw results in the atorvastatin and the normal control with Vijay-Sar group. Now, for any drug to work on atherosclerosis, it can have one of these many effects. And I am particularly talking about the herbal drugs. So it may have lipid lowering effects, which have been reported by these authors in anti-diabetic models of rodents. There have been reports of decreasing the lipid oxidation, which we also saw by the decreasing the MDA levels, perhaps. Inflammatory properties also, there are reports of INF, interleukin 6 and TNF alpha, and suppression of the cholesterol accumulation has been reported. But there have been no reports of direct action of these anti-sclerotic actions or anti-thrombotic actions of Vijay-Sar. We did not, although we are not reporting any anti-inflammatory properties right now, but Vijay-Sar has shown some promise in this direction in cataract patients. So we concluded that there was an improvement in the lipid profile, which was seen in the decreased triglycerides and increased HDL lipoproteins, also which was reflected in the histopathology of the aorta. The antioxidant stress markers like MDA was decreased in the high-fat diet which was given Vijay-Sar. Although I would like to bring out that there is a limitation of sample size, but probably Vijay-Sar can provide as an add-on therapy, which may be beneficial in retarding the progress of atherosclerotic lesions. Thank you.
And I think there must be some questions are going. Dr. Alam, Mr. Alam. Our mind dedicated, please, sir.
Yeah, I think
you started your talk by giving the objectives. When you started your strategy of the model, generally, we have to have a concept for giving, for going to the ethics strategy, for getting the advice on giving what that. So, why do we don't generally go directly to the animal model? You must have to have in vitro some models. So, have you performed any experiments to suggest that these in vitro models are encouraging, very encouraging results?
So with rodent models, we've had experience, but particularly with Vijaysa, this was our first study. We did have, so there was literature on animal models of rodents with anti-diabetic effects. So Vijaysa has an established anti-diabetic effect with antioxidant activity. So, and the established model,
Generally, when you go for getting the animals from animal sensitivity, they will always ask that why should we use animals directly unless you show or give us the proof in that in vitro studies we have had some intelligence. That's one. You can use the leukocytes.
Yes. So cultures.
One culture, two culture.
So this is something we've been able to do. We want to do vascular intelligence to muscles because they are problematic.
She also has
I just want to ask you, did you mention the rodent species?
Star rats. My bad, I missed it in trying to rush.
Yes. Of mice or species. And what's the rationale behind this study?
So, like sir was also fine. So there is atherosclerosis is normally you have a high prevalence of that. So to get Vijaysa seemed like a promising drug which might retard the progress of atherosclerotic disease. So obviously we cannot directly go into human trials.
स्क्रीन शेयर में प्रॉब्लम आ रही है
Sir,
स्क्रीन शेयर कौन सा
Yes.
For the same kind of indication.
No.
इसी में
एक बार ओपन कर इजी
So, although it is difficult to get established this model in rats, but this has been established by Ray et al. Long back. So we've.
So the because is
Yes.
What she is saying is now obese rats are a different stage.
Yes, not
You can use obese rats are. So I think all the questions are very relevant. You are young, sometimes you move on to to discuss your work.
Yes.
It's always there. Thank you, Dr. Bharti. So
Thank you.
we have another lecture. Yes, we have been chaired by Dr. Saurabh Khanna. Dr. Saurabh Khanna is head of the paramedical science department. Besides, he is a senior faculty member, associate professor in the department of physiotherapy, and has been in Jamia Ahmedabad for a very long time. He was awarded PhD. Very rare in such kind of disciplines to have PhD degree. He has published about more than 40 papers and has also contributed to the chapters and has got academic excellence award at World Physiotherapy Congress and also been associated awarded as the best academician by Global Association of Physiotherapy. And so many. Besides being a teacher, he is also the sports secretary of the university, so making a lot of contribution to the students' life. So Dr. Saurabh Khan will be presenting his topic on the biomarkers in osteoarthritis and role of physiotherapy and potential therapeutic approach to combat inflammation mediated diabetes. So let us hear from
Honorable Chair, Professor Alam Saab, all the degrees on dais, of the dais, and dear colleague and students. As sir told, I am a physiotherapist, and we physiotherapists, we are very poor in research. But I have tried to have a collaboration with the scientists like biotechnologists, molecular medicine professor. So I did something on the role of physiotherapy and molecular marker. Okay? It is my first effort in this field in India. So as we all know, osteoarthritis is a very common disease nowadays, and it is affecting everyone. Everyone is suffering from neck pain, back pain, knee pain, and it is very common nowadays, and it is affecting overall. Especially, it is more affecting the allied people who is working in sitting position. Earlier, the established reason was biomechanical and genetic. But nowadays, whatever damage has been happening in the joint and cartilage, the reason of damage is mainly the marker. Until now, we are diagnosing this disease with the help of X-ray and MRI, which is only showing us the picture when damage has happened. So when damage has happened, there is only one treatment available, that is replacement. And India is a poor country. Everybody could not afford the cost of replacement, as well as you don't have a tertiary care hospital throughout the India to perform replacement surgeries. So what is the other hope? Even pharmacology is doing a lot of researches to find out some disease-modifying drug which can combat the damage process of the cartilage. But till now, they have not succeeded. There are some researches available in the literature which are showing exercise is also having some role in modifying these markers which are responsible for damage. So I did a narrative review to bring some highlight on all these issues. As we discussed, arthritis is very common and affecting mostly all of the major load-bearing joint, and everyone is affected nowadays. Even after 40, earlier it was a disease of 7th decade of life, but nowadays we are getting people who is having this problem in the 2nd decade. We have got a patient or person who is in 20s and having neck pain, back pain because of this prolonged use of mobile and poor posture, long hours sitting, etc., etc. So I'm going to discuss what are those markers and how exercise is going to affect those markers and prevent the arthritis. This marker has shown their efficacy in the diagnosis as well as prognostic of the arthritis. So there are 4 groups of markers which are important in diagnosis and prognosis of the arthritis. First group is the collagen metabolism marker. They are CTX1, CTX2. These are the common marker. They are regulating the collagen metabolism, and they have been increased in serum or in the plasma who is ever having more chronicity of the arthritis. Second group is the non-collagen protein, that is COMP, cartilage oligomeric metallic protein. The concentration of this cartilage is also increasing if the arthritis is progressing. Third group is inflammatory factor like interleukin. We have 2 groups. One is pro-inflammatory, and other is the anti-inflammatory like IL-6, IL-10, TNF-alpha. They are causing inflammation, and the other group is IL-4 and IL-10. They are acting as an anti-inflammatory marker. So they all have a very important role in the osteoarthritis. Fourth group is the synovial lutein marker, hyaluronic acid, okay, which is basically responsible for the lubrication of the joint. So these 4 groups are having their potential role in diagnosis and prognosis of the arthritis. So we will see here how these markers has been affected with the help of exercises. So past experience with disease modifying osteoarthritic drug clinical trial indicate that pharmacological agent must demonstrate testing safely and consideration, but they fail. Till now, there is no researches available which can say that I can modify or I can stop this disease by giving this drug. So the hope is only relying on the other alternative medicine or exercise. Physical exercise has been shown to exert a beneficial prevention and therapeutic effect on the almost all pathogens of osteoarthritis. It is affecting overall. It is affecting the physical parameter as well as molecular both. So the need of this review was to bring some insight of the how these markers has been affected with the help of different kind of exercises. I have done reviews. I have taken the article with the keyword of molecular marker, osteoarthritis, and physiotherapy and exercises, and I have found the very few articles has been found in this regard, and the result is this.
First is effect of exercise on the biomarker of the inflammation. Aerobic training and squatting exercise up to 60% of the knee flexion were found to be increased soluble TNF-alpha and receptor 1 and decreased TNF-alpha in the patient with serum indicate decreased severity of OA. So it has been shown by the researchers if we perform exercises, that is aerobic exercise. There is a lot of exercises we are prescribing. Some are high intensity exercises, some are moderate intensity, cycling. So even in exercises, there are some exercises which are going to have bad effect on the marker. They are going to increase those marker, and there are some exercises which are beneficial. So that is the second research will be done. But TNF-alpha concentration is decreasing after exercise in the serum level, so it is going to decrease the inflammation and pain. Second is further studies found that active exercise and asymptomatic exercise significantly reduce TNF-alpha in the synovial fluid. Home-based exercise and stretching exercise, strength and flexibility training significantly reduce serum IL-6 level in the OA patient. So whether it is TNF-alpha or IL-6, all are going to be decreased in serum level after exercise. Second effect of exercise therapy on the acute phase of protein, active and asymptomatic exercises significantly reduce CRP in synovial fluid. It means creatine phosphate is also decreased after aerobic exercise. Effect of exercise on therapy of biomarker derived from synovium. Aerobic exercise and resistance training of 6-month intervention showed a high level of serum hyaluron in the exercise group than the control group. Hyaluronic acid which is going to strengthen cartilage, okay? It is going to increase the capability of cartilage to withstand more load. So this hyaluron is increasing after exercise. Effect of exercise on the therapy of the marker of the bone metabolism, like CTX1 and CTX2. CTX1 is responsible for the bone resorption. It means it is causing more and more damage. Since CTX2 is responsible for calcification of the cartilage destruction. So the concentration of both has been decreased after exercise with the help of physiotherapy. Effect of exercise therapy on the biomarker of the derived from cartilage, serum CMP level of significantly reduced the exercise group, and patient was followed interval walking actively brought CMP level to baseline in osteoarthritic individual. So there are a lot of research which are showing these all marker has some beneficial effect after exercise. Moderate physical activity and aerobic exercises are reduction in the MMP13. Their CTX2 level were reduced by 4 months of supervised training. Acute drop of AR aggregane in response to high intensity exercise was observed in both OA and healthy group. Aggreganes is also responsible for cartilage health, and it has been shown with the if you are doing high activity exercise like prolonged walking, it is also going to decrease the aggreganes in your serum level, and decrease of aggregane is increasing it is going to weaken your joint. This is diagram. You can see over here how this marker are going to damage the joint, and like IL-6 and IL-beta, TNF-alpha, CRP, they all are decreasing after exercise, and IL-4 and IL-10 is increasing after exercise. IL-10 and IL-4 is the anti-inflammatory marker, and how these markers are going to damage the joint. Conclusion. Exercise therapy is not only affecting the physical marker, like you can see cartilage remodeling, increased strength, decreased pain, decreased inflammation, increased endurance, increased range of motion. All these things, all these physical variables can be effectively improved with the help of exercise, and it has been proved by the various researches. But the role of physiotherapy and the monitoring of the effect is still need some more researches. How these exercises are going to have some role on the marker is necessary nowadays. Thank you so much.
Thank you, Dr. Shora. So, Dr. Shora has presented a very important topic, which may invite some questions. So, these questions I think he is doing very fundamental, doing the molecular aspects, molecular aspects of the osteoarthritis, and also practicing on patients, because these patients in physiotherapy units are in hundreds every day. So कोई क्वेश्चन है? Any questions to Dr. Shora? आप पूछ रहे हैं? हाँ बेटा, उनका माइक देखिए। शादी
I just want to ask that how do you evaluate CTX and PNL levels, whether it's their classification or by another more micro, or by estimating CTX level and PNL.
And what we did during our research process, we have taken 2 ml sample after getting ethical approval from the university. We have taken 2 ml blood, and it was freeze in -30. We have extracted serum from the blood, and it was from blood. And after that, we have done ELISA, to find out the concentration of the markers. Ma'am, it was serum. Yes. Thank you.
We have another lecture by Dr. Priyanka Sriram on the topic carbohydrate assisted combustion synthesis of new white light emitting biodiesel plus or WLEDs. So Dr. Bhavna is representing
कौन सा?
the very prestigious college, Goa College from Bandhavgarh, and this principal of college is also here. So we informed that college has A++ grade by NAC. So Dr. Priyanka Sehrawat is assistant professor in the Department of Chemistry, and she is in the editorial board of Advances in Applied Sciences and reviewer of several journals of prestigious publishing houses. And she has 50+ research papers, plus more 1,200+ articles, and H index of 23. So at this age, very good and very excellent achievement. And she has won Best Poster Award, Best Oral Communication Awards at many conferences, and besides she is also CSIR mid-qualified associate professor. So welcome, Dr. Sehrawat.
Thank you so much, sir, for your kind words. Good afternoon, everyone. The topic of my today's presentation is carbohydrate assisted combustion synthesis of new cool white light emitting dysprosium dog BYAZ2 nanophosphors for WLEDs. This is the outline of my today's presentation. So if I talk about WLEDs, so India is witnessing a tremendous progress in science and technology and has emerged as the third largest producer of power with a 371 gigawatt high potential. And this is the picture showing the evolution of lighting industry, like from incandescent bulbs to CFLs to LEDs, with better lumen output, longer lifetime and fast switching. Now, this is the basic impact of solid-state lighting technology on the India gate. The first picture is before 2012 and the second picture is after 2012, after the implementation of WLEDs there, and we can easily see the difference in their lighting quality. Now, next are the applications of nanophosphors. They have tremendous applications from display to warning panels to signboard to interior state setting, fluorescent lamps, advanced ceramics, cathode ray tubes. Next is the solar panel, indoor cultivation, and latent fingerprinting detection also. Now, what is the futuristic goal in this lighting industry? With the implementation of these smart WLEDs, it is projected that 67% of the energy can be saved by the year 2030 with the implementation of these smart WLEDs. Now, next is the synthesis of dysprosium BYAZ2 nanoparticles, a highly energy efficient technique. Solution combustion synthesis has been adopted to synthesize these nanoparticles. This is the outline of solution combustion synthesis. First of all the raw materials, they have been dissolved in deionized water. Then this homogeneous mixture was kept on hot plate for 5 to 7 minutes. Then it was heated inside muffled furnace at 500 degrees Celsius for 12 minutes. As a result of the combustion reaction, a spongy product was obtained, which was crushed in the agate mortar to foam powder. Then this powder was calcined again inside the muffle furnace to attain the desired nanoparticles. Next is the characterization of nanophosphors. Various characterizations have been performed, like morphological analysis has been conducted via GEOL JSM 6510 SAM, Tec9 G2FEI TAM. For crystal structure and phase analysis, Rigaku Ultima 4 XRD has been implemented. Elemental analysis has been done by Amitec EDEX, and the luminescence properties have been studied by Hitachi F7000 spectropluorometer. While for band gap analysis, Shimazu UV3600 plus TRS was executed. Next is the results and discussion. So basically, these are the XRD patterns of the dysprosium doped nanophosphors. As we can see, that the recorded diffraction profiles of the target sample, they are well coinciding with the standard reference one with COID number 2002754, indicating the phase purity of the synthesized nanoparticles. Next is the retweeled refinement of the optimum composition, and we can easily see the better fit of the experimental and the calculated data. Next is the important aspect of the synthesized nanophosphor, since we are claiming their applications in the WLEDs. So for that, photoluminescence properties, they play a key role. So the dysprosium ion basically shows light in white spectral region as a result of the two peaks. One at 485 nanometer, that gives blue color, while second one at 579 nanometers, that gives yellow color. As a fusion of this blue and yellow color, we get overall white emission. Now next is the PL excitation spectrum of these nanoparticles. Since this excitation spectrum has been recorded in the near UV region, basically 300 to almost 500 nanometers, and we can easily see the highest peak at 355 nanometer. That indicate the role of these particles in near UV based white LEDs. This is the PL emission spectra of the synthesized samples. These two peaks are visible, one at 478 and other one is 579 nanometer, blue and yellow peak. Now next is the PL emission intensity variation with dopant ion concentration. So we can see first the intensity increases, reaches up to the highest value. That marks the 5 mole per cent sample as the optimum sample, and afterwards it starts decreasing due to the known radiative transfer of energy amongst the nearby dopant ions. Next is the SAM, TAM and SAD analysis. Since the good morphology of the nanophosphors help in the better packaging in the WLED. So it also plays a key role. And from the SAM, TAM and SAD analysis, agglomerated spherical particles with size around almost 50 nanometers are shown. Next is the EDEX spectrum analysis. This marks the elemental purity of the synthesized particle. From this figure, we can see that no any foreign element is present. That means the synthesis procedure of these nanoparticles, it has not introduced any kind of impurity. Next is the decay curve analysis. So basically, the mono exponential nature of these decay curves depicts the homogeneous distribution of dysprosium ion and also the presence of single center for this dopant ion, that is yttrium ion. Next is the digital photographs of the samples under daylight and UV light. In the UV light, we can see the white emission of these powdered samples. Next is the CIE chromaticity diagram of the nanophosphors. Utilizing the PL emission spectra, we can clearly see the CIE coordinates are lying in the white region that marks their white emission that can be utilized in the WLEDs for various lighting purposes. Next is the conclusion. So in summary, these nanophosphors have been synthesized successfully by highly efficient solution combustion synthesis. The CI color coordinates are situated in white region that marks their potential applications in the near UV based WLEDs. This is the list of my research publications. So if I talk about my future work, we will try definitely for the fabrication of these smart WLEDs from the synthesized nanoparticles in coming future. And in the end, thanks to all the organizing members to organize this wonderful international conference. Thank you so much.
Thank you. So any questions to Dr. Priyanka? Any questions from the audience? So if none, I must thank.
Thank you so much, sir.
And making your presentation. So all the presentations are over. Dr. Shafi. So presentations were very valid. The structure was very nice on the Krebs cycle and reverse Krebs cycle. Very fundamental basic cell biology and cell chemistry. Quite good. And the other one was by Dr. Bhavna Mandu. She did work on the
क्या नाम है तुमसे लास्ट स्लाइड दिखाना
various markers of
एक्चुअली उसमें से कट हुआ प्रेजेंटेशन आपने कट कर लिया है थे ये ध्यान था
then before it arthritis onset and how they can play an important role in equally important and very interesting message was the
वेंडर पे कर दो
organic committee to come to the conference and attend their work. So thank you. And one thing I must compliment, every speaker of parliament time schedule, it is generally there.
Thank you so much for conducting the session within the stipulated time. So now I would like to request our seminar chair to present a memento to the session chair.
Speakers
देखना सुना रहा है
शुरू करने
Thank you.
Now I would like to go forward with technical session 4. It will feature also 4 oral presentations from the distinguished speakers. Please be inspired by their expertise. This session is going to be chaired by Professor K.K. Gupta, Agarwal College, Ballabgarh. So Dr. Krishnakant Gupta, Principal of Agarwal PG College, Ballabgarh, brings a wealth of experience with over 33 years in teaching and administration, including more than 13 years as a PG principal. Holding a PhD in physics, he has an impressive record of 334 research publications, 15 co-authored and edited books, and numerous conference contributions. So Dr. Krishan has several international engagements within USA, Japan, Spain, Taiwan, Iran, Mexico, and etc. So he is an active participant in academic and research bodies and has received various awards displaying a commitment to excellence in higher education. So may I now request Professor Krishnakant Gupta to chair the session, please.
I welcome you all to the last technical session. So it will be followed by poster session. But I regard all presentations in the last session. At the outset, I thank the organizers for providing this opportunity to chair the session. In fact, in this session, we have 4 oral presentations. By this time, this session should have been finished because the schedule was 4 p.m. But anyhow, we will conduct it and we will try to manage the time. I would request the speakers to take not more than 8 minutes for presentation and followed by 2 minutes discussion if it is there. So, without wasting time, I would like to invite the first speaker, Dr. Mohammed Akram. Is he here? Please come. From the University Jamia Hamdani University and Life Sciences. He is a good researcher and he will be presenting what the role.
Assalamu alaikum. And first of all, I want to thank the session chair and the dean sir and the chair of seminar for providing me the opportunity to share my work with you all. So the topic of my talk is de novo HSV2 infection in human fibroblast cells induces IFI16 mediated inflammasome and cytokine response. As all of us know, these human herpes viruses are significant human pathogens. Almost around half of the world is infected with HSV1 and around 500 million people were infected with HSV2. And these herpes viruses have a specific property, that is, they establish latency in specific tissues, that is called the specific tissue properties. And based on the cells in which they attain the latency, all herpes viruses are divided into 3 subfamilies: alpha herpes virini, beta herpes virini, and this gamma herpes virini. And most of the members of alpha herpes virini family, like HSV1, HSV2, and VZV, they establish latency in sensory neurons, while members of the beta and gamma, they establish latency in T lymphocytes and B lymphocytes. These herpes viruses are large double-stranded DNA viruses, they envelop viruses, and they replicate within the nucleus. And these genital herpes infections are mainly caused by HSV2. Up to 85 to 95 or 90% HSV2 infections are due to HSV2, and some by also HSV1. And these herpes viruses, to successfully colonize, they need to evade the host innate immune response at all stages of infection. And inflammasome formation is one of the part of the host immune response. And these inflammasomes are multi-protein complexes that recognize the pathogens or danger-associated molecular patterns. These inflammasomes are made up of cytoplasmic proteins or protein sensors like NLRP3 and AMP2, or nuclear sensor, that is IFI16, an adapter protein, that is ASC, apoptosis associated spike-like protein containing CARD, and effector protein, that is procaspase-1. And these inflammasomes, they induce the secretion and activation of pro-inflammatory cytokines like IL-1 beta, IL-18, IL-33. So here in this study, we just to check during HSV2 infection, what kind of inflammasomes are produced or activated, and this is the secretion of IL-1 beta cytokines. Here we use HSCC cells and HSV2 virus from HSCC and different
methods like we detect the IL-1 beta detection by ELISA, did the Western blotting, CoIP, IFA, as well as the PLA. Here, figure 1 shows this HSV2 infection, it activates the inflammasome formation. In figure 1b, here we detect the quantity of IL-1 beta produced during infection and in the absence of infection by ELISA. So here it is clearly indicates that the HFF cells, they secrete more IL-1 beta during the infection period as compared to the uninfected cells. And during the infection also, the level of IL-1 beta secretion is almost equal at PFU1 and 2, that is 18.5 picogram per ml and 18 picogram per ml. In case of 5 and 10 also, we have the almost equal levels of the IL-1 beta secreted by the HFF cells. So this secretion or production of IL-1 beta is independent of the dose or titer of the virus. So here we can say this HSV2 infection leads to the secretion of IL-1 beta. Here in B, we Western blotted the whole cell lysates from the HFF cells from uninfected as well as from the infected one with different PFUs of the HSV2 at 4 hours post-infection. That is 1 PFU, 2, 5 and 10. And Western blotted for I516, uncleaved test phase 1, cleaved test phase 1, and actin is used as a equal loading control. And the level or expression of FI16 and uncleaved test phase 1 was seen clearly in infected cells as well as the infection with 1, 2, 5 and 10 PFUs of the HSV2 at 4 hours post-infection time points. It means this FI16 is an innate DNA sensor which is present in the cells, and the expression of uncleaved test phase 1 FI16, they are continually expressed by the cells. While the cleaved test phase 1, this is the indicator of the activation on inflammasome. So the level of expression of cleaved test phase 1 is very less in uninfected cells, but maximum at 5 PFU of HSV2 at 4 hours. So this HSV2 infection is responsible for the conversion of inactive test phase into the active one, which further indicates the activation of inflammasome. Then we did the CoIP as well as the Western blotting, and CoIP for ASC and Western blotted for FI16 and RP3 and M2. Here, whole cell lysates of HFF cells were produced or were prepared from uninfected as well as the infected cells at 4-hour, 24-hour post-infection. Here, ASC was found to be associated with the FI16 in infected cells, not in the uninfected one. Hence, it is clear this HSV2 infection induces the formation of IFI16 mediated inflammasome complex. While in panel the second lane, ASC is also found to be associated with the NLRP3 in infection at 4 hours and 24 hours both, while FI16 and ASC infection was not seen at 24 hours. It was gone at 24 hours. Initially, it was present. So here we can say IFI16 mediated inflammasome as well as the NLRP3 associated or mediated inflammasomes were activated. While in case of M2, the expression of M2 was present in uninfected cells, but association of ASC with M2 was not seen during the infection period, both at 4 hours as well as the 24 hours. In the last, this D figure, it shows the whole cell lysates were prepared from the uninfected as well as the cells infected with HSV2 1 PFU at 4 hours and 24 hours post-infection. And Western blotted for NLRP3, FI16, M2, test phase 1, and ASC, and actin was also used as a equal loading control. The expression of NLRP3 is present both in uninfected cells as well as the infected cells at 4 hours and 24-hour time points.
while Fi16 was not seen at 24 hours but present at 20 in uninfected as well as the infected cells with the 4-hour time points. Here, M2 expression was present in uninfected cells as higher level as compared to the infection with 4 hours time point. Again, the same level of expression at 24 hours. Spase1 is also expressed in uninfected as well as the infected cells at 4 hour and 24 hours time point, as well as the SC also present. And here we can say the expression of SC in uninfected as well as during the infection was not responsible for the difference in the inflammasome response. And this inflammasome response is totally based on the DNA sensors like NLRP3, Fi16 and M2. So from this figure we can conclude this HSV2 infection leads to the maturation and secretion of IL-1 beta as well as the activation of the inflammasome, both NLRP3 mediated as well as the Fi16 mediated. Then we further do the immunofluorescence assay followed by the PLA to see the association of Fi16 and SC protein. Here we take HFF cells, uninfected one as well as the infection for 2 hours, 4 hours and 8 hours post-infection time points. And here the second antibody is conjugated with the electrophore 488 and this Texas red for the ASC and green one for the Fi16. So in uninfected cells, nuclei of the cells are stained with the DAPI, shown in blue. So this during the in uninfected cells, there is no association of Fi16 and SC was observed because most of the Fi16 was present inside the nucleus and SC was present outside the nucleus in the cytoplasm mainly. During the 2 hours and the 4 hours post-infection time points, these blue arrows and the white arrows, they show the interaction of ASC and Fi16 inside the nucleus by blue arrows with the yellow punch star. It shows the yellow punch star means these are the positive signals which showing the interaction between ASC and Fi16. And very less individual Fi16 and ASC were present in the cytoplasm in the nucleus. At 4 hours also, but at 8 hours, there is no interaction of Fi16 with the ASC. Most of the ASC is present in the cytoplasm. And then this B figure shows if we increase the PFU of the HSV2, then what happens? It means we are using the more dose of the virus or titer. So in this state, the complex or the association of ASC and Fi16 is more as 4 hours and 4 hours as compared to the panel A. So here we can say this ASC and Fi16, they are associated and activate the inflammasome formation. And here we check because NLRP3, M2 and SC, they are the most predictable proteins which interact with the ASC. So we check the association of these NLRP3 and M2 with the SC also by using the same experiment. Here most of the NLRP3 and ASC, they are present in the cytosol, but there is no association, there is no yellow punch star shown in the uninfected one. But during the infection, in the cytosol, there is association of NLRP3 and ASC shown by the white arrows. While in case of M2 and SC, there is no association of M2 and SC, which indicates there is no inflammasome formation just because of this M2, and HSV2 leads only the Fi16 mediated inflammasome formation, not the M1 or M2 mediated inflammasome formation. So we can conclude this de novo infection of HSV2 in HFF cells leads to the formation of inflammasomes which contribute the production of IL-1 beta, and it favors or induces the formation of nuclear Fi16 and SC or Spase1 inflammasome complex. And this Fi16 is a innate nuclear DNA sensor It finds to identify the HSP2 genome in the nucleus, and it does not favor the AM2 inflammasome formation. In the host cell responds to HSP2 infection by activation of Fi16 and NLRP3 mediated inflammasome formation during the early time points, but not at the later time points. And this work is supported by the grant that is DBT Wellcome Trust India Alliance grant sanctioned by Dr. Maharaj Madhukari. Thank you.
Thank you, Dr. Now I invite the second.
Thank you.
Thank you. Poonam is from Honda Institute of Medical Science and Research, and she will be talking about genetic heterogeneity and oxidative stress in silicon. Madam, you have 8 minutes. Please stick to that. 8 minutes.
Sure. Genetic heterogeneity.
एक मिनट ये ना जेनेटिक
Very good afternoon. So, the topic of my presentation is genetic heterogeneity and oxidative stress in COPD. Hello, myself Poonam. So, what is COPD? The COPD is actually the chronic obstructive pulmonary disease, which is a third leading disease worldwide right now. And it is characterized by airflow obstruction, and which is irreversible process. And this is because of inflammation, which is the inflammation which is caused by the oxidative stress. So, firstly, there are two conditions of COPD, which is chronic bronchitis and emphysema. In chronic bronchitis, there is a deposition of mucus in our airways, which retard the flow of blood and everything in our airways. And in emphysema, this is the industrial or occupational hazard. There is an endothelial dysfunction or the damaging our endothelial tissues, which retard or which interrupt the exchange of air in our lungs. So these two conditions conclusively makes the COPD worse. So if we talk about the pathogenesis of COPD, there are so many responsible factors which are responsible for COPD. So there are smoke, dust, pollution, and our genetic predisposition. So these factors, which in fact are there at our genetic level, which mutate the gene at genomic level, which makes our defected protein, and these protein which is further responsible for the damaged lung tissues, which directly responsible for the COPD development. So, what is oxidative stress? As we all know, oxidative stress is the imbalance between the free radicals and antioxidants. So, if the imbalance is, this imbalance responsible for the oxidative stress, and oxidative stress ultimately lead to inflammation, and this inflammation is responsible for the COPD development in the patient. So, these are the effects of oxidative stress, like lipid peroxidation, DNA damage, bronchoconstriction, cell damage, etc. So, in our study, there are two proteins, MMP2 and TIMP2. MMP2 is matrix metalloproteinase 2 enzyme, and the TIMP2 is tissue inhibitor of MMP2. So, the TIMP2 binds with the MMP2 after phosphorylation, and it inactivates the MMP2 protein,
because it is responsible for the extracellular matter degradation in our lungs. But when it, because of any mutation or because of any factor, when the TIMP2 is not able to bind with the MMP2, so the MMP2 becomes active and it starts degrading the extracellular matrix of our lungs, which helps in the pathogenesis of COPD. So, what is the significance or the need of our study is, like COPD is a chronic inflammation lung disease, which is very well known globally. And this is a very unique study because it has not been done in our Indian population. And the third is these are interrelated genes like TIMP2 and MMP2, which are interrelated to each other and responsible for the COPD development. And because we live in Delhi, and as you all know, Delhi is a very polluted city, and the dust, smoke, these are also like smoking and dust pollution are responsible for the development of COPD. So we did literature survey. So there are so many population where the MMP2 and TIMP2, these two proteins have been studied, like Chinese, Egyptian, Japanese, Central Bulgaria, Iran, Mexican. But this study is not, it has not been conducted in our Indian population. If we talk about the result, so our first objective was the study of detection of SNPs in MMP2 and TIMP2 genes. So what we did, we extracted DNA from the whole blood sample and run on the gel electrophoresis, and we have seen the whole blood DNA segment in the gel electrophoresis. And after that, we took 8 set of primers from the literature reviews, and we did the sequencing. So after sequencing, we found out that there, out of 8 SNPs, there are 3 SNPs like in MMP2 1 and TIMP2 there are 2 SNPs which showed prominent result in COPD and control groups. So in COPD and control, we can clearly see the genetic heterogeneity and the genotypic and allelic frequency in our control COPD group. So which was very significant. And in TIMP2, there were 2 SNPs plus 8 at 853 position and at -4180 position in COPD and control group, which was very significant, which ultimately showed the imbalance between the TIMP2 and MMP2 protein, because in COPD, the TIMP2 becomes very low, which ultimately lead to the inability of TIMP2 binding with the MMP2. So it was unable to bind with the MMP2, so MMP2 becomes active. And it starts degrading the tissues of our lungs, which ultimately lead to COPD. We can clearly see the difference between this MMP2 and TIMP2 level in COPD and control groups. So we also observed oxidative stress cytokine expression. So in HMGB1, IL-6 and interferon gamma, there was a high level in COPD group and control group. Same was the BWF, VEGF and NE, the neutrophil elastase enzyme, which was also very high level in COPD group and control group, which also shows the endothelial dysfunction in the COPD patients. And these graphs showing the oxidative parameters like melandialdehyde, glutathione, superoxide dismutase, and NO, which was also very high in COPD group than control group. So if we talk about, so these smoking and dust pollution, genetic predisposition, these are responsible for the mutation in TIMP2 and MMP2, which ultimately led to the mutation in these proteins, and so TIMP2 becomes very low, so it is unable to bind with the MMP2, and so the COPD happen. So if we discuss all these things in our mechanism, the cigarette smoke is very important factor in the COPD development. So these smoking, because with every puff, there are so many oxygen particles enters in our lungs, which are responsible for the starting or activation of inflammation, and these inflammatory molecules like TIMP2, MMP2, NEToxils, MIF, GATA1, AP1. So there are so many factors which are responsible for the inflammation and COPD development. So this was all about my COPD study, and this is the recent publication of this on COPD on role of oxidative stress and genetic polymorphism of MMP2 and TIMP2 in COPD. Thank you so much. Any queries? If somebody want to ask anything, so most welcome.
Thank you for finishing in time. Any question, please? No question, then let us thank the speaker.
Thank you so much, sir.
Now our third presenter is Mr. Amresh from Thermo Fisher. He will be talking about scientific liquid chromatography product portfolio. So you have 10 minutes. You will excuse me, and the stage is there.
कौन से ICL हमदर्द ये अमरीश वाली कहाँ से पॉइंटर फॉरवर्ड एंड बैक अच्छा
So, good afternoon, one and all present here. I think my time starts now. Okay. So, good afternoon. We are here in the vicinity of international seminar on recent advancement in chemical and life science, organized by the Indian Society of Analytical Scientists. It's an honor for me to be here with you today. My name is Amresh and I am from Thermo Fisher. So right from morning, we have been discussing more of the scientific papers, and we have seen that Dr. Shrivastava's talk, he was talking about the GCMS for VOC studies. Then he also discussed about this cardiovascular disease. Then also he mentioned some instruments. Similarly, Dr. Manoj Utpeti, he also discussed about the slurry in petroleum. So he had two kind of applications. One is to identify what is there in petroleum slur, and then what kind of microbes are important to nullify that, to detoxify that. So we come into the picture as a instrumentation that we are here to identify what is there in your slur. It could be organic compound, maybe inorganic compound, or it may be some metals or something else. So all I wanted to say is that instrumentation is the key core driver for any research nowadays. So we are coming from the instrumentation background. So we are here to accelerate your application, your scientific research in a faster way. So just a brief introduction about our company. Our mission is to enable our customers to make the world healthier, cleaner, and safer. We have around more than 40 billion company, and we spend almost 1.4 billion in the R&D, so that new and new instruments are coming up with the faster applications. Now, our global team delivers an unrivaled combination of innovative technologies. So we have Thermo Scientific, you can see Applied Biosystem, Invitrogen. These are our channel partners. These are our core subdivisions. With this, we are working with the system. And then we have the unique
customer value proposition, because for us, customer is number one. So that is very important for us. So partnership with the customer to accelerate routes to market support, regulatory compliance, quality focus. So these are the key drivers in Thermo Fisher to help our customers. One slide just about our company in India. We have many application labs to support you here, like we have in Indrapuram, Ghaziabad. Then we have in Mumbai, Bangalore, Ahmedabad. There we are putting our instrument, and we are calling all the scientists to come and work with us so that we can generate good number of publications. And we are here under one umbrella. You can see we have the unique propositions where it is available for the diversified sectors like healthcare, life science, applied market, like universities also and colleges. This also comes in the applied, pharma and biotech. So these are the overall domain to bring under one umbrella is the mission of Thermo Fisher. Now coming to the technologies, we have HPLC, GC, IC. Morning, Dr. Srivastava has discussed about GC. GC actually is one term. Then we have GC, GCMS, GC MSMS, GC Orbitrap. There are a number of variations. Similarly, LC, LCMS, MSMS, LC TOF, LC Orbitrap, so many options. Then you can see this IC, isotopic ratio mass spectrometer, is so enable instrument that it can find out that from, like, for example, if you take tamarind, so it is from the which part of the country you can find out. Whether it was taken before the rain or after the rain, we can find out. So it's in a very, very high research domain we are in. So with this instrument, all we have, GCMS, ICP-MS, ICP-MS, AAS, ICP-MS, OES, these are being used for the metals. Then GC is being used for the volatiles, like morning Dr. Srivastava was talking about VOCs. So that can be done on the GCs. So that also we have. Apart from that, we have LC, liquid chromatography. So here also we have number of options. Vanquish Core is for the routine applications. Then we have Vanquish, which is for the high profile. And then we have Horizon, which is having the back pressure of 22,000 PSI, which is highest in the industry. Then we have the new HPLC, which is for the nano applications, especially like proteomics, metabolomics. Then you need a nanoflow in the LC. So these LC is being used for the low flow. Since time is concerned, so I'm moving a little fast. So this is one unique proposition we have is called Vanquish Duo, wherein we have two LC applications simultaneously. Because mass is working very fast and LC is slightly slow. So you can have one LC having two LC together, and you can combine with mass spectrometer. Then online LC 2D, we have just discussed about a few presentation. And then we have purification LC. So there are different combinations of LC we have. And then we have LX and TLX. This is for the high throughput of, you can have 4 channels together, which is again a unique proposition to fasten your application areas. Now we have a different detectors also. Diode array, variable wavelength, fluorescent detector, refractive index, charge. This CAT detector is very much common in, especially in the application of petroleum. So these are the unique propositions we have as far as detector is concerned. Charge aerosol detector, I will not go much because time is concerned. Not only that, we have the connections also. So these tubings, you can see it is having 0 dead volume, and you can tighten it with the fingers. So these are the options that are given in our system. And then coming to the LCMS and HRMS. LCMS, as I said, liquid chromatography, mass spectrometry. LCMS has 2 ways. One is when you know your sample and you just wanted to understand, okay, Mr. Instrument, tell me what is present in your sample. So you can just instruct to the instrument that, yes, I am looking for these 10 molecules only, 20 molecules or 30 molecules, whatever you want. And then instrument will find out for you. So that is called targeted analysis, right? When you have a target, you know the precursor, you know the product, and your triple quadrupole will be the better option. So we have single quadrupole, triple quadrupole. We have got LC HRMS, which is also called Orbitrap. In some of the application I have seen just before me, People are talking about the lipoproteins and many other diseases, biomarkers. So all those biomarkers can be established with the HRMS. We have Orbitrap here. Just to give you an idea of what kind of instruments we have got triple quadrupoles. These are the single quadrupoles and ion trap. Then we have the triple quadrupoles, these two. And these three are said to be the Orbitrap, which is the hyphenated technology of triple quadrupole as well as Orbitrap. Orbitrap is known for the high resolution. Whenever you are working with the proteomics and especially the disease kind of scenario, you need to have the high resolution. When I say high resolution, that means it goes from 1,20,000 to 5 lakh, even up to the 10 lakh resolution. It gives a very high resolution. Why do you need it? Because you need to separate the precursor ions. So this is very important. Then we have two photos here. You can see this is called tri-bit series. Tri-bit series means it is having the combination of 3 instruments: quadrupole, then we have ion trap and Orbitrap. So all 3 together, once in a single box. And this instrument is used by AIIMS Delhi. Then ICGB, NII, all the premier institutes are being used. Delhi University North-South Campus, NDTL National Dope Testing Lab, and THESTI in Faridabad, THSC translational research they are doing. So they all are using this kind of instrument. These are the 3 triple quadrupoles, new models. And the application which it can do is the environmental, food safety, pharma, toxic, and clinical translation. So morning we were talking about the sludge from petroleum, which comes under environmental. So these 3 models are very crucial, and these 3 models, difference between these 3 models are in the sensitive mode. So the highest one, it can go up to the 15 lakh is to 1 signal to noise ratio, which is one of the industry's best. This is again triple quadrupole. So we have been talking more on the triple quadrupole, but just to make you understand what is triple quadrupole and how it works, just basics. You have an inlet wherein your molecules from HPLC is coming, right? And this is in the form of LC now, form of molecules. Then it goes to the source. And this source is making this molecule in the ionic form, because any mass spectrometer is working in the ionic form. This is not reading the molecule, but the ions. So to make them ionized, you can have ESI, APCI, or APPI to make them ionized. So then this is analyzed, and then data is collected here, and then processing comes here. So this is the diagram of any triple quadrupole across any vendor. This is the features of one of our base model, which is called Fortis Plus. You can see it can go as high as 1,50,000 sensitivity. Then there is another model, Quantis Plus. It is a mid-range instrument. It can go up to 5 lakh is to 1 sensitivity. Because as I said, the difference between these 3 models are mainly the sensitivity. And this is the top of the line model, Altis Plus, which can go 15 lakh is to 1. And this is being used by NII also recently. And many other people are using, especially I think one in IOCL also they have purchased. Now to Orbitrap. Orbitrap is well known and well established. Oh, how can I go back? Yes. So these 3 models are there. New series, Exploris 120, Exploris 240, and Exploris 480. These are the new series. The rest are the older series. Idea of showing you is that most of the proteomics application you can do with Exploris 240 or 120. These are what are the application areas, thrust area. So you can see here metabolomic application, proteomics, translation research, biopharma, contact research. These applications you can do on this kind of instruments. And this is all about the Orbitrap. This is how Orbitrap is working. It has a outer electrode and inner electrode, and then ions are moving, and they are producing the image current, which is then transferred to the image current is transferred to the mass to charge based on the FTMS. And this is the easier way to understand what Orbitrap is. We all are aware of this kind of scenario. And this, I think we all know. So this is how Orbitrap is working. Software, we have number of softwares for different applications. Small molecule analysis, we have libraries also. Then proteomics sample, the PD and BF are for the protein analysis, quantitative analysis. One interesting point I just wanted to mention here is Chromeleon. Chromeleon is very useful for the capabilities for the compliance and data integrity, which is have the centralized comprehensive set of audit trail. So we talk about this trace finder software. So these are some analysis has been done on the same software. You can see the Olympic Games, Nestle. These are some key users, those who have used this kind of instruments. Consumables. So these are a whole set of consumables. Idea is to present this is to make you understand that Thermo is not only into the box selling. We have everything related with that. So including your columns, you can see separation device, GC column, tagging, vials, everything is together under one umbrella. These are the columns. So we have Acclaim, AccuCure, and HyperGoals. So this is all about, these are different columns for the different applications. So this is all about from my side. So now I'm open for question answers, if any, and as.
I can say that they are the leaders. You need any instrument, they will provide.
Thank you, sir.
Let us plan for it. We are delegates, the rest of the presentations will be hall number 2. Now we will, all of us will shift to hall number 2. Let's go there.
Yes, thank you very much, sir.
Before that, I would like to request the speakers of the oral presentation to receive the certificate from the chair. Dr. Mahipal Yadav, please come on to the dais. Dr. Poonam is here. Dr. Priyanka Sehrawat.
Please don't move out of the hall.
Hall 2 में चले जाएं. Dr. Saurabh Khan. Dr. Bhavna Mattu. And Dr. Muhammad Akram. Now I would like to request the conference chair to present a memento to the session chair.
I request all of you to kindly move to hall number 2 for a very important lecture. All of you are requested to go to hall number 2, please.
This is the final lecture of the
Final
conference.
Yes.
ये भी मेरे पास.
हॉल नंबर 2 पे आ जाइए सब लोग.
हाँ यहाँ हो गया.
चल बेटा लैपटॉप निकाल ले, आजा.
सर वैलिडेटरी के लिए तो लैपटॉप की जरूरत नहीं है.
नहीं वैसे बोल दो.
सेल तो यहाँ हो गया पूरा.
हाँ सर, यूज अनयूज वाला दूंगा तो जो हो गया यहाँ का.
हाँ यहाँ हो गया. इसको बंद करके
हाँ, अरे वहाँ अब्दुल नहीं है, निजाम. मैं तो
एक मिनट अभी
रखना पड़ेगा भी तब तक शायद सेल बस बचे हुए ज्यादा वापस ये लो जो लग गए इसके अंदर निकाल देनी हम इसमें से। हाँ दो लग गए, 2 और 2 4 2 6 लगे हैं। ये लो 2 सही है इसमें, ये काम आ जाएंगे तुम्हारे। ठीक है, यूज में कर लेना। अरे बेटा निकाल ले लैपटॉप अपनी। हैं क्या हो गया? लैपटॉप
प्रेजेंटेशन वहाँ पेनड्राइव में दे दो, बोलो वहाँ पे कर दो ना यार।
ये रख दो, हैं ये बंद करो,
कर दो सब बंद।
निकाल दो लीड, निकाल दो।